literally. I'm trying to find where my office is going to be.
Oh, and Leo just got it. Yes, they're about to say.
Perfect.
My first time ever working out.
If we are supposed to be here, we can
So yeah, anytime. I'm available.
Yes. I would love to learn some shoes. They said about their auditions. But they, like ours also says. Like, it's ridiculous classes that count. I'm going to, yeah. My first day together.
Good morning, folks.
We went to light blue today. Nice.
How are you guys? Good morning.
Thank you for checking us out.
Thanks for showing up. Thanks for
It's going good.
Good morning. I'm Leo Gordon. I'm the Vice President of Career Technical Education here at UFD. I am hosting this great event today, and I don't take any credit for any of this because Kristy is her team are the reason why you guys are together. I just think of the food. I'm glad you guys are here today. I want to take some time to thank our sponsors, and forgive me if I screw this up. Macrocycle Technologies, Beyond Benign, STEMteachersNYC, Con Ed, and Deutsche Bank. Those are the sponsors, I believe, that helped you guys put these great things together. The Engineering Green Economics Initiative, spearheaded by WISE, is super important to us, and it fosters innovative connections and collaboration between educators, industry, and policymakers in the UFP. So it is important to us that you guys have this forum to exchange ideas and connect with others, like-minded educators, because the future, our future, is dependent on our young people understanding sustainability, green, and all the different things that are happening that are changing daily in our environment. We're at a critical juncture here. And I know you guys all understand it because you're here, but it's important that we understand that these changes that are happening, a lot of us have immediate concerns, obviously, legislative-wise and all the different things that are happening, but it's more important that depending upon where you are, you're connecting with young people so that they understand these things. You know, if you are in education, you know our young people are connected one way and one way always through social media. They're looking at their cell phones, their iPads, and they're getting information that's sometimes not 100%. So it takes us as educators to share what we know so that the young people can make valid choices and make factual decisions and understand what's happening. That's why this convening is so important. Today, I challenge you to make connections with some people in this room that you've never made connections with, because you guys are like-minded. Share ideas, share your concerns, so that you guys can take this back to the individuals that you impact each and every day, so they can also start creating a bigger network. I do appreciate you guys' time, because this is super important for me personally, because my young people, I have 2 young daughters, and their concerns are bigger, I think, than our conversations. And often we look at the young people as, you know, don't worry about it, we'll take care of it. But our young people are the persons that will take this one on beyond our age group. So I thank you for coming. Thank you, WISE, for keeping this up. I know how difficult it is to put something like this together and keep it ongoing. Ideally, when we do this next year, we double the size. I challenge you guys that are today to connect with another teacher that you know cares as much as you do and try to further this network of great minds that we can keep this at the forefront of education, at the forefront of policy. And I'm here to help you guys in any which way that I can, because I know how important this is to you and it should be important to them. But, you know, the world we live in. So thank you guys for coming. Enjoy the day. I will be in and out. We have a bunch of different conferences here. If you guys need me, I will make sure that my information is left in the back table. I'll send Sade up with some of my cards if you guys want to connect with me directly. If I can help you with something that you're doing at your school or even with the companies that are here, let me know. All right. Thanks so much. Enjoy the day.
Thanks, Leo. I'm David Anderson, President and CEO of WISE. Welcome from us to this sixth annual EDGE conference. A couple of thank yous to begin with. First, obviously to Leo and the UFT. I've said this many times before, from your partnership with the UFT on a whole variety of fields. But in some ways, I think this one is the most important because the UFT is doing so much, as you're aware, in the green and clean arena. So there's a really wonderful fit between what you're doing, you know, with your organization, Moderator University of Public Schools, and what we're trying to do with the EDGE program. And it's also great thanks to our sponsors of the funders of this conference and the funders of the WISE Institute and the EDGE program, Edison, America's Foundation. It's their funding, of course, that helps us offer the EDGE seminars in schools around the city, as well as helping to pay for the cost of events like this. So thanks to them. You know, I think Leo, it's clear, we're all aware that we're at a crossroads, and I'm not going to be political, but I think it's very clear what drill means. And so the outlook, on one hand, is if you're a glass half empty person, you think, well, you know, we're in for trouble, and obviously with the temperature rising above 1.5% last year, I say, well, you know, it's all over, but it really isn't. You know, amid the doom, I suppose there is really a very, very positive energy, and that's because of so much of what's taking place on the ground. And you know, I'm sure you read every day that there really are, at the microeconomic level, a lot of really tremendous things being done to help the world become a more sustainable place. And that's why, you know, having a conference like this, bringing people together who are doing this wonderful work, is so important for learning. And it's events like this and the glass half full approach is what we're from when it comes to the EDGE program. As Leo has so aptly said, you created EDGE, Kristy created it. I really want your students to, you know, sort of find a pathway through the negative fog, so to speak, and develop a positive sustainability mindset and learn not just about climate change and extreme weather and so on, but all the other aspects of sustainability, whether it's buildings, transportation, supply chains, finance. Today's topics, concrete and plastics. So, you know, we're, like you, so invested in helping your students become, if they're not already, more passionate about a future sustainable world, and secondarily, the opportunities for careers in sustainability, which is very much a high demand field. So we're thrilled to put on conferences like this, and we're very grateful to the speakers today who are devoting their time to share the great things that they're doing in this arena, and especially thanks to you because of your commitment and your passion about a topic which I think, frankly, is shaping the future of our world. So thank you very much all for coming. Thank you to our speakers. Thank you to the UFT, our sponsors, and last but never least, to the WISE team, Kristy and Sheila, and all the WISE team put on it. You know, these things don't just, it's not a wipe on, wipe off thing. They do take a lot of work to put on it, and so they do a fantastic job. So thank you. Before we dive in, one more welcome from Joanne Carter, who is with Con Edison, and she's going to add Con Edison's welcome to today's event. Stwart, thank you.
Feel like I'm like. I'm gonna stand over here. So welcome. It's great for, that we're able to sponsor such great events, and it's also great that you guys came out. And, sort of near and dear to me, and, I'm a lawyer. You're probably like, John, stop telling us about your personal life, but I promise it will have a common theme. So I'm a lawyer by trade, but actually when I started out in my career, I was a teacher. So I used to teach first grade, elementary education, and all of that, and sort of I then pivoted because I found the law fascinating. So I say that in the sense of I always remembered early on in my career how important and frankly, I still use those skills now with adults. When I'm talking to them, I have to go very slowly. Step two, no, not good. Step one, so it still works with those skills. And, I say that too, also with Con Edison, as David already mentioned, some might say we're in an alternate universe. Others might say we're living in times of crisis. Others might say, like my daughter, I was telling Brian earlier, we're living in the century of doom. My 6-year-old has said that. But with all of that, we all still have a goal. And Con Edison still has a goal, and Con Edison is staying true to that, which, as a company, we are staying true to advancing and helping the state reach its climate goal. We are staying by that, that we have not veered from that, despite, what's happening in the government, and we're always going to continue to progress. And part of that too, which rings true throughout Con Edison and really some of the work that I do for the company is really focusing on making sure our communities are brought along, and maintaining resiliency when it comes to clean energy and climate change. And that is definitely a focal point for the company and personally for me. It's sort of, I'm in this a little bit of a new role, where I lead the strategy for the company that leads to our philanthropic giving. And I say that because not only did the company transition, and it is in a transition in the sense of clean energy and moving towards 100%, but they realized too that really all pockets of the company need to be brought along into that transition. And so what did that mean for us? That meant in our philanthropic side of things, that meant changing all of that. And so as part of that process, we pivoted away from the arts. Don't worry, we still love the arts, so don't leave here being like, Kana doesn't like the arts. We just took a different direction. We support the arts and directions. But what we did is we wanted to highlight and work with nonprofits that are really propelling it forward when it comes to climate change. You guys know New York State has some very, very ambitious goals, reducing greenhouse gases and net zero. And what we realized too is we can't do all of that if it's just content. We need the partnerships and communities that we serve. So that's one thing. And the other thing I'll go back to is just resilience. We are all facing, get it, it's a lot going on in the world, but at the end of the day, we're still here. The other point too is that we are still facing the effects of climate change, whether people want to believe it or not. It is here, and we are directly impacted. I know during the summer we're all burning up because of the island effect, and also we're impacted too by flooding and all of the extreme weather. Not too long ago we had Prospect Park that was really on fire, and then we're facing that in California too at times with fires. So the point is that these are imminent, and it's great that you guys are able to come together and learn and grow and be able to teach you as we go forward. My hope too is that as we continue to bring folks together, that we'll all learn, take each other's perspectives, and create something beautiful for the future. Because as I view it as a campfire. We want to leave the campfire, better than when we came. And I think about the youth and the young folks that you work with, even adults that you might work with. That's what we want to do. We want to leave people feeling better than when they came and met you. So, and I repeat, Con Ed, we are staying the course, and everybody is very passionate about the immediacy and the need to focus on climate change and the effects that it's having on our folks. And so we're we're there in it, and, you know, the one theme I will say is resiliency. We're trying hard to make our communities resilient and really listen to them. Thank you.
Thank you, Joanne, for your words. I mean, I think it's comforting to hear, you know, we're still all working towards the same goals. So we're very grateful for that. And so I do take your feedback very seriously, so please do fill out the survey at the end of that event. But, you know, we do a lot of talking at the very beginning, and we don't have a chance for you guys to get to know each other at the very beginning. So by the time lunch comes around, and you don't have a lot of time to spend with each other, so I have a little icebreaker. Not your typical icebreaker. It's not, you know, is a hot dog, a sandwich, but we'd like you to write down on the white paper here, on the card here, we're going to fold it afterwards, just what you want it to be like in a year, or what you think it'll be like in a year. So it could be either way, want or what you actually think it's going to be in a year. And then in 2030, you know, was supposed to be, you know, these mile markers and all these things that we're supposed to achieve, and then we're pushing it to 2035, and now it's 2040. But let's go back to 2030 and see how that is. So write that down, take a minute, and then just, you know, talk to your folks, and then maybe we'll share out a little bit of that. So we take maybe like 5-10 minutes to do that, talk to each other, and then you can do it on the New York scale, New York City scale, New York State scale, or a national scale, if you like. I think the international folks kind of know what they're doing, so we're just going to stick here in the US. And so, yeah, do that, and then talk to each other, get to know each other.
This is it.
You do it too.
Yeah?
Oh, it's we're gonna keep them, and if you hear them, we're gonna revisit them.
Oh, boy. That's an interesting one. Yeah. How's it going?
I was really.
Yeah, how's everything?
Right, it was.
How you guys doing? Running the drinks? Easy getting it. Yeah, no problem. My parents live in, well, I grew up in Kobe, Long Island, so it's right on the L at the bar, up on that station. Take a train. Made it here easy. Nice. I'm also in Long Island in Glenhead, yeah. Trains were like today.
Yeah.
We're from home Friday, so.
That's true. Well, that's right. Today's Friday.
Nice.
I'm learning the train. I'm in Bergen County. So I took the train to Hoboken and I took the path. And I think it was my first
corporations continuing to reject climate experts, writing them off as alarmists.
Everybody kind of feeling the same way. Or is anybody else like feeling differently? Yeah?
I'm feeling some of that, obviously, but I also think that like in 1 year, there's the hopes for more youth awareness around climate.
Oh, nice.
Yeah.
Very nice. All right, 5 years, anybody? I just want to make a prediction on 5 years? Yes, yes, go ahead.
I think there'll be progress. I mean, I think there's still gonna be progress now. It's slower and not probably what we want, but it's kind of moving towards education, resources. So the nice thing I think instead of well too is you can pivot. So there's so much work to do in climate. There's local, there's city, there's state. So federal, it's not your thing. It's private industry. Like there's so many. There's always something. Whereas I think about maybe other things that people are working in. And maybe there aren't as many places to pivot, but there's always something.
So I think it's really interesting to like think about, you know, all the other levers that we can use to make change and to move forward. So that's really good. Thank you for that. So we will be collecting it so that, and if you can put your name on it, it'd be great. If you come back next year, we'd like to revisit this. It'll be fun. All right, so our next speaker, because I promised, sorry, I can't seem to, what are you trying to do? We're just moving forward. Okay. Our next speaker is Peter Koklanos.
Koklanos, yes.
Koklanos, from LiRo-Hill. And interestingly, he's the architect, the structural engineer and the other architect here of the Liberty Island Pavilion.
Wow.
So, but, you know, he has all these amazing accomplishments for the city and building some of them really wonderful things like the Brooklyn Botanical Gardens, the South Garden renovation, and if you, most of the things that you see in the city, you know, this company built, so it's kind of cool. And of course, he is a civil and structural engineer, which is kind of like awesome. And then, he has a civil engineering degree from Syracuse and a master's degree for structural engineering from Stanford. So welcome, Peter, to talk about low carbon concrete.
Thanks, Kristy.
What do you think of you guys?
A little bit more about myself. I pride myself on being a New York City public school product. I went to school, started at PS 193, PS 194 in Flushing. And then went to high school at Townsend High School. With a lot of work on the humanities and literature side, and I was more of a math and science that I found, but I still found my way into engineering at the end of all that. But yes, thank you for having me. And I'm going to be presenting on the latest and greatest in low carbon concrete technology. So I'm going to talk about the why. Why is it important to us as practitioners? Where are we today in the science, and where are we going? So as you can see on the screen, the area and field that the construction sector, about 17% of the work that we do contributes to the total global greenhouse gas emissions that are produced. It's significant. So the work that engineers, architects, contractors, and the policy behind that has a huge impact on overall greenhouse emissions. Now, zooming a little bit further, what are the impacts of various materials? About a third of that is related to concrete or concrete production, from the cement, the aggregate, all the different components, the additives that go into it. Concrete is definitely the biggest part of the pie here. And when you look at concrete itself, about 7 to 8% of total global greenhouse gas emissions are related to manufacturing and delivery. And when you look at that, we call that embodied carbon. And embodied carbon is basically a calculation of how much
carbon dioxide is being produced through that manufacturing process. So why does concrete produce so much carbon dioxide? And it's a result of the actual process that it's made. We basically take ground limestone or clay, right? It's ground to fine particles, and then it's put in a clinker where it's heated up to about 1400 degrees Celsius. So it's a very energy intensive process. So there's carbon dioxide that's produced in the breakdown of calcium carbonate, which results in calcium oxide and the emission of carbon dioxide. So 40% of that CO2 emissions are from the thermal emissions, the actually heating process, and the other 60% are through that calcination process of the limestone. So I talked a little bit about embodied carbon. Embodied carbon is the calculation of that production of carbon dioxide in the mining, manufacturing, and delivery process for concrete. That's also referred to as global warming potential. Now, I was actually on a panel yesterday with the New York City Department of Buildings, and they're looking at instituting GWP, global warming potential limits, on concrete for almost every project in the city. It's major policy change. The Port Authority of New York and New Jersey has already instituted GWP limits. The city will also be probably putting these limits into place within a year or so. That's going to be impacting how concrete is produced, how it's sourced and manufactured on projects in New York City. So there's three main things that as designers we try to look at in terms of sustainability, right? Reduce, reuse, recycle. Reduce is the best thing you can do, right? You're totally eliminating that from the equation. Then as engineers and architects, we try to figure out how can we reuse things and repurpose them or put them back to the system. And then recycling is taking stuff out of the landfills, trash, byproducts, and then incorporating them into our design. So the piece that we can mostly impact as practitioners is the specify low carbon, right? And building more cleverly, building more efficiently, and being a little bit smarter about how we do things. From a policy standpoint, we always want to promote reusing existing structure, reusing existing buildings, maintaining existing buildings. Knocking down buildings and building new ones is very costly from an environmental standpoint, right? So trying to find the intrinsic value in maintaining, repurposing something is really valuable. And as designers, we're always thinking about how can we design a structure today to meet the needs of tomorrow. So if it does need to be repurposed, how do I enable that to happen so that I'm not designing something for this specific purpose or point today? Maybe it's a manufacturing warehouse. Maybe that manufacturing house wants to become a production facility tomorrow. Today, one of the biggest challenges we're facing in the design industry is how do we take office buildings and convert them to residential, right? After COVID, we found that we needed to repurpose a lot of this building stock. We don't have enough affordable housing in the city. So now we're trying to go in and redesign these buildings that were never designed for residential purposes. And it's a huge challenge because no one was thinking that way when they were originally designed, right? So where the partitions are placed, where the elevators are placed, and how the space is laid out, not really conducive to a residential apartment style development. So as designers, what can we do with concrete to make it more efficient? On the reduction side, right, there's things like post-tension concrete. So that's actually a high strength draped carbon wire tendon that is only where you need it, right? So it's where the tension is in the slab, rather than having a complete mat of rebar on both sides of the mat. That's a smart way to reduce the thickness of the concrete and put in the reinforcement where you need it. The other thing we're seeing use of are what's called void form slabs. So if anyone's seen a waffle slab that's got kind of big cavernous holes in it, it's again where you have enough concrete material to reduce or to handle the forces involved, actually leaving spaces so that you're not just pouring dumb concrete or wasting concrete in that process, finding ways to void out those portions of the structure that don't require that material. Pozzolans. So pozzolans have been around a long time, and a lot of them are byproducts of a lot of other manufacturing processes. You'll see here fly ash, slag, and silica fumes. So these are byproducts of coal, iron production, and also silica production. they can actually be put into cement as a direct replacement of cement, up to a range of 40 to 50% replacement. And that's substantial because cement is approximately 40% of that global warming potential factor that we were talking about earlier. There's also now ground glass, so recycled glass is being ground and put into cement mixes. The picture on the bottom left, some of you may recognize that building. That's 270 Park. That's the new JP Morgan Tower. They actually replaced 40% of their cement with ground glass pozzolan, which is astounding. And that's a building that's got concrete strengths up to 60,000 psi. So really pushing the envelope of what we can do. And then there's Portland limestone cement, which is limestone cement is a technology that dates back hundreds and hundreds and hundreds of years. It's a different manufacturing process that's been well established in Europe. Essentially, it doesn't require as much manufacturing or grinding of material. It also reduces the heat involved. So we're actually looking to incorporate that in all of our concrete materials in the city by a level of up to about 15%. So on the circular design side and taking things out of the waste stream again. So on the aggregate side, if you've ever seen a site where we mine for aggregate, right? Where basically we're drilling down and we're taking a huge mass of material out of the earth. Why not take things out of the landfill, whether it's tires to create crushed plastic, polystyrene, which is essentially a form of styrofoam, coconut shells, electronic waste. I've even seen recycled computer waste being used for aggregates. So rather than using actual gravel and stone and concrete, replacing with some of these materials is feasible. Reuse. So after the project is completed, maybe you're looking at demolishing a structure. How do we reuse that material? So you can actually take concrete, you can grind it down and crush it to about an inch, and then reuse that as a subgrade rather than going and mining natural stone, right? So reutilizing that as much as possible is important. As designers, not only thinking about the service life, but how do you demolish the structure, right? Because that can be very labor intensive. Kristy mentioned Matt and I's project, Liberty Island Pavilion. We actually had a design goal to be able to demolish the structure within a few days. It was a 15-year lease. The National Park Service didn't want this thing there forever, right? Because they're trying to contain the ecology around the Statue of Liberty. So we actually designed the entire structure as a kit of parts that could be taken down within a couple of days. So that's something that impacts every single decision that you make in terms of how are we bringing concrete on the site? Are we welding in the field, or are we bolting? Bolting can be a lot easier to demolish and take down than something that's fully welded up. So being a little bit more forthright in your decisions and thinking about not only the current use of the building or the intended use, but what's going to happen afterwards, right? When you go to demolish it or try to repurpose it. Some emerging technologies that are starting to come out, carbon sequestration, which is essentially taking CO2, liquid form of CO2, and actually injecting that into the concrete so that we're actually taking some of that byproduct and putting it into the mix. And there are a few companies out there now that are pushing this. This is one of my projects. This is in Battery Park, not too far away from here. It's a coastal resiliency project where we're designing for the potential flooding of tomorrow. We're putting a lot of seawalls and elevated berms, but we're also lining a lot of these seawalls with concrete that is able to grow marine habitat on it. So not only are you creating structural resilience by holding back those floods, but you're also creating a habitat for shellfish and oysters to be able to grow and survive on that habitat. Other things that are coming out there in the industry, these are more forthcoming technologies, I would say. So looking at the actual production of concrete, right? So utilizing things like plasma and electric kilns, hydrothermal energy, which uses a lower temperature for production of concrete, 3D printing. So this is actually a 3D printed concrete structure where a machine basically takes a 3D model, reads the design, and is able to lay out a 1 inch, typically a 1 inch bead of concrete and it lays it out over the course of the structure. This is, I think this is going to become a more and more popular way of construction, especially where labor costs are starting to really drive up the cost of residential construction, especially. We're going to start to see more of that. Some carbon negative or bio-based concretes, hempcrete and algae-based concrete. These can be used as more of an insulative material. These are products that in the form that can actually draw carbon dioxide out of the atmosphere. So these are some technologies that are currently being developed and studied. And then long-term durability, which I think is really important. We design these structures, but then they start to fall apart after 30, 40, 50 years. How do we design them so that they're lasting 100, 150 years like they used to, right? So finding different solutions that allow concrete to self-heal, allowing them to recalcify as moisture is introduced to the structure, to the concrete, that they can seal up these cracks. So these are things that are currently out there. One of the main reasons when we study structures, things like the Parthenon and the Colosseum. How did they last so long, right? Because they were using limestone cement back then that was able to self-heal and last the test of time. So we're actually going back and looking at some of these structures that have lasted the test of time, and how do we change what we're doing now to incorporate some of that self-healing component. Any questions?
Do you find there's enough, a sort of, business awareness around the sustainable value of these approaches, either the private sector or city or state, since we, no longer have the federal government that values, or acknowledges climate risk?
No, the answer is no. I think a big issue beyond awareness is communication, and I know I might be jumping on some of the panel questions later, but it's not only being really smart about the science and technology. The industry, our industry, will be slow to adapt because a lot of the things I'm talking about here require an upfront cost. And if, as a developer, if you're only concerned about upfront costs, which most developers are, you have to have incentives and initiatives to promote these things for the greater good or for the long-term benefit. A lot of these things have a long-term benefit, right? If I'm paying a little extra for the design mix, that's going to give me a 50-year product or 100-year product rather than a 10-year product. That's going to reduce my maintenance costs, right? My heating costs. But if I'm worried about how much does it take me to build this today, then there's a disconnect there. So from a communication standpoint, from a policy standpoint, it's important that we train not only our students, but also our peers and also the people that we report to, that we need to look at things a little bit differently when we go and we make decisions, whether it's repurposing a part of our facility or building, or, hey, why can't we put a green roof on this facility and make it as an adaptive space that can maybe take multiple purposes. So we need to really work a little bit extra to communicate these things all around, up and down, in order to see them come to fruition. Yep. Question.
You mentioned converting office buildings into affordable housing.
Yes.
Have there been any examples, say, before, of where that actually has been realized? I mean, I can understand what you mean, that every apartment is basically a bowling alley because there's one window. So
Yeah.
how do you, unless you have a corner apartment, what's an example?
So unfortunately, there was a lot of zoning regulation that in New York City that was probably was largely in place for the course of 30, 40 years, and through an initiative that the mayor's council, city planning is putting forward, they're actually changing the zoning laws. First time in a long time that allows these types of adaptations to happen. So rezoning and repurposing things. I don't have any specific examples to tell you about, but I can tell you that it is happening. It has to be studied on a case-by-case basis. There isn't a one-size-fits-all approach, because at the end of the day, you need safe egress out of the space, right? You want to try to bring daylight into the space, fresh daylight. So you have to still find a way to meet code. So those challenges are real. You might have to change your vertical transportation, have in one central core. You might have to add stairs on the corners of the building now from a residential perspective. It's not an easy thing to do, but I know that zoning change that's going into effect now will allow it to happen more often, more frequently.
Right across the street, on Wall Street, Stwart building that was office space, and it just opened probably 8-9 months ago. It's now residential, it's not affordable. It's not affordable. It's not affordable. It's not affordable at all. But to watch, because I'm here, my daughters are in construction, I watched, and we were very close friends to Local 3. We watched this go up. And for them they had to keep the fascia of that building because it's a historical building. For them to demolish that building, brick by brick, from the inside out, was amazing. I'm sure there are going to be architectural classes that talk about that development that happened right across the street. It was a gut rehab. And the apartment, not affordable by any means. I mean, these apartments are millions of dollars, but watch that happen. And they reused, I don't know the number, but I believe it was 80% of the things that was pulled out of there was recycled and reused in some way, shape, or form. Great. If you guys want the Whole Foods there, I don't understand how it stands up because Whole Foods is there. You can walk through Whole Foods, that whole building is standing on which is.
Yeah, just converting office space, obviously, for the reasons you're saying, because there's a lot of zoning things. Is there still any energy or effort into restoring old, like dilapidated, already residential buildings that are like in disrepair?
Again, this is where the policy comes into play, and the initiatives come into play, right? I think the policy does impact how these things happen from a market retail standpoint, right? A residential developer is going to look to extract the most value out of a property, right? And unfortunately, knocking something down and rebuilding it will allow them to generate the greatest cost per square foot or revenue per square foot most times. But I think it's incumbent on our policymakers, our practitioners to take a look at our building stock, and we have a lot of aged building stock. I always, when I walk by something, like there was a building there yesterday and they knocked down, they're putting something up right where it was. It's terrible. We need to do a better job of incentivizing reuse of these existing facilities.
Is it possible without having policy lead the way? Like it would have to be financial, so it would have to be in policy.
It's got to be financially viable, right? And sometimes in One Wall Street, that example that was raised, they sounded like they literally had to demolish the interior of the building, right? So they had to scaffold the facade and then rebuild it from the inside. I can tell you that project probably costs more than building it from scratch, because you're going in with a scalpel and you're doing major surgery on something. It's typically a lot easier, faster, more cost-effective to build from scratch. So finding ways to incentivize that, whether it's tax rebates or technology to make it a little bit more cost effective, is going to be important. Yes.
Yeah. Yeah, it's kind of a similar question because you were talking about recycling of concrete, like crushing it down and
Yeah.
using it. I was just curious, like, how common is that? Is that like economically viable? Is it typically cheaper to just use new materials to create concrete, or is that like common practice?
It's extremely common. It's called RCA in the industry, recycled concrete aggregate. It's most commonly used in non-structural applications or beneath roadways as a subgrade material. You can use it as drainage fill. There's even technology out there that's using recycled glass as backfill material, as aggregate. So it's very commonly used. Even asphalt. Most new roads that are being constructed have some level of recycled asphalt in it, typically a very high portion. They mill it up, they take those millings and they incorporate it back into the process.
It's like pretty local, right? They're doing it not far from the site.
Oh, absolutely, yes. concrete and asphalt is a very local process, right? It's gotta be within an hour of the site, otherwise it doesn't really work. Yes,
Kind of looking back at structures, there was building now techniques for to keep the structural integrity and stuff. So
Yep.
what kind of new things are actually being implemented, I guess?
yeah, it's specifically the big industry push on the concrete side is use of limestone cement. So it's called Portland PLC, and the big issue is that our manufacturing is not set up to process limestone same way that we produce typical Portland cement. Portland cement is has to be ground to very, very fine particle size, and then it's put in the kiln. Limestone has to be processed separately, and it's typically needs to be ground to a specific particle size. So the industry right now is trying to adapt to that because it is being specified more by practitioner designers specifically, but it's from a durability perspective, it's a much more durable product because it has these self-healing properties involved. But our manufacturing is not there. It's probably going to take a few years, and it's going to be very regional by the time we get there. But these are things that are happening today, and there's codes and standards around it as well. Yes.
So in your slide before, it was the triangle with the
Yeah.
cycle. So one of I think the biggest chunk was like build nothing.
Use less stuff.
Chunk, yeah. So
Yes.
are there any? I know it's kind of weird because your job is to build stuff. It's how we all make revenue. But like, are there any conversations within industry or with conversations with like municipalities, like maybe we're not going to build everything we thought we would, or we don't need to build certain things?
Well, use less stuff doesn't mean you build it. It just means you can renovate and repurpose, right? Because things are constantly changing. Facilities, even well-maintained facilities have to go through updates, right? Not only that, the code is constantly. I was talking with David. Our building code changes on a 3-year cycle now, right? So things like the other big thing is ADA compliance, right? Accessibility for folks in need. A lot of the facilities that were built in the 60s and 70s were not ADA compliant, so we're going to repurpose and rehab facilities to become ADA. So there is never a case where doing nothing is an option, but doing it more smartly and repurposing and making sure that facilities are being updated and maintained, and that we're designing them to be able to be updated and maintained is the piece I'm trying to bring across. Yeah. Yes.
That comes up when we learn about like stormwater runoff, and that's a potential engineering solution of like concrete.
Yes.
I also like, oh, are we? But I want to get actually.
It's funny. I had a slide on that and I took it out. So I've done full hour presentations on rainwater, stormwater management because it is a big component. That's more on the civil engineering side. It's a big problem, right? And New York City has a combined sewer system, a CSO system. So when the system is over inundated in the first hour of a major storm, system backs up, right? And we have major problems, right? And now you've got wastewater that's going into our waterways and canals and rivers and streams, and it wreaks havoc on the system. So we have to find ways to slow down the detention of material or detain the material in the stormwater before it's released into our sewer system, or we have to find ways to naturally infiltrate it into the ground. Yes. Yes. Yes.
So, by the way, Rutgers offers a green construction champion class that you can take for free. And I learned in that class that permeable concrete is not as great as everybody recommended, but permeable asphalt they do. And that one they seem to have better success with. So
Yeah, what happens with things like permeable concrete, permeable pavers is that once the cores get clogged, it doesn't work anymore, right? So it requires more maintenance and upkeep. You got to power wash it pretty regularly. So, but there's a lot of other There's a lot of other methods you can use. Bioswales are really cool, where you're basically planting a pit, like a tree pit or something, and you're basically creating a cavern that can absorb a lot of stormwater. Again, you're trying to create capacity in the ground before you have to put it in a pipe to a sewer or an outfall that goes into a river. So there's underground storage tanks. There's lots of things you can do that are out there. The city and the DEP are constantly updating their requirements and regulations with these things, but there needs to be more done to help with that, because it is a major issue that the city faces with our combined sewer system.
Concrete himself, what is that? I don't know.
So concrete, as it deflects, it bends, it cracks, right? Because concrete's very strong in compression, weak in tension, right? So as soon as concrete deflects or bends, you start to get tensile cracking. So concrete that can self-heal is concrete that can close those cracks on its own without you having to go in and do like epoxy injection or things like that. And if you can prevent concrete cracking, then you extended service life by fivefold, right? Because now the rebar that's in there is not going to be exposed to moisture, it's not going to rust, it's not going to corrode, and then start popping the concrete out. So concrete that can self-heal is concrete that can close its own cracks, and that's usually through, for instance, limestone. Limestone will leach, like sometimes you'll see it on natural stone where it'll leach out a white substance right on the surface. Basically, it recalcifies as water hits it. It'll actually be able to close and fill those cracks up and crystallize in those cracks. Yeah.
Does it require moisture? Is that?
Requires moisture, yeah. Typically, the limestone cement concrete requires some moisture to be able to recalcify. Yep.
So, because you blew through my brain, what you were talking about with injecting CO2 into
Sequestration, yeah.
What does that? What does that mean?
So, carbon sequestration, carbon capture is a big one. So essentially, you're taking carbon dioxide that's produced either from the concrete manufacturing process or other processes, converted into basically a liquid form, and then it's injected into the concrete manufacturing process. So it's not really taking CO2 out of the environment. It's taken out of other manufacturing processes and then reintegrated into the concrete mix. It's kind of similar to what we talked about with the pozzolan replacements, right? The fly ash, the slag, silicone fume. You're taking that as a material and you're importing it into the concrete. Interestingly, you think, okay, does that make the product worse? Incorporating fly ash, slag, and silicone fume typically makes the concrete a denser mix. It's actually typically a better product. So these have been actually out there for some time. There's no reason why they shouldn't be specified, but I can tell you that there's specifications of various city agencies that don't incorporate this as a standard, right? Because again, there's sometimes the various agencies and the industry slow to adapt unless there's regulatory changes that push these things forward.
Thank you so much.
Thank you.
We have a break now. I'm going to collect your papers, and we have a little break. You don't need to go to the bathroom. It's on this side and on the other side. And you can go watch plastics. All right, hopefully you guys have a good time and talking to each other. I wanted to introduce our next speaker, Stwart Peña Feliz. He's really from New York. He lives in Massachusetts now, but he's really from New York. He's a chemical engineer from Cornell and another degree from MIT. And so, you know, I think I was so excited. First of all, it's through our EDGE committee that we are able to find these amazing speakers for you. We wanted to really think about how we can reimagine materials, not just the typical reduce, reuse, and recycle, especially recycle. So, you know, I was looking for a startup that would be a great person to come and talk about the thing that we all use and hate, plastic. And of course, Stewart is the perfect person because I was like, oh my God, this is such an amazing technology. So I think that you'll really enjoy this conversation, and Stewart, will you take it away?
Thank you very much, everyone. It is my honor and my pleasure to be here. My name is Stwart Peña, and I am the CEO and co-founder of Macrocycle Technologies, the venture reimagining how plastic recycling works. So I'm going to take a little different approach from Peter. By the way, Peter, I think we're wearing the same color. We did not plan this. But I want to take this opportunity as well to say thank you to all the villages that raised me to get here. I'm a true believer that it takes a village to raise a child, and I am a product of many villages. So as far as that thank you, I wanted to speak a little bit about my journey and my story as to how I got here. And hopefully you guys can learn a few things as well, because I would like more people and more to be in this space, because we're going to need an all hands on deck approach to be able to resolve this crisis that we're facing. And after that, the second half will be consistent of what Macrocycle does and how we're trying to address the plastic crisis, the waste and the emissions associated with their production. But with that, I have to click into it. Yeah, I got it. Yep. Perfect. So I was born in the Dominican Republic. And at the age of 11, I moved to Long Island, New York, specifically Copiague. For those of you that might not know where Copiague is, it is right next to Massapequa, Amityville, Lindenhurst. So right here is a picture of me in chemistry class. And I usually put this as a pixelated picture to show that a few years have gone by since then. New York really brought me up from the beginning. I came in the 8th grade, and although I didn't speak English at all, I still love the math. I still love the sciences, and those things really helped me just catch up, learn quicker, and I was very focused on my studies, especially because coming from a country where I had, comparatively speaking, a lot of resources, but the country itself didn't have those resources. When I saw that food, well, not food free, but when I saw that sports were free to participate in, or when I saw that my parents didn't have to pay for school, those things was like, why wouldn't I take advantage of all those resources? And with that, I was really motivated to follow the American dream. And with that, I was very lucky then to get into Cornell, where I studied chemical engineering. And it wasn't easy. Things definitely got very complicated, but I was very lucky to do a lot of cool things in the chemical engineering space. And when I got into Cornell, I was really passionate about how global energy works. My dream was to democratize access to energy. In the Dominican Republic, I saw how the electricity will go out because of a poor infrastructure. So in order for me to resolve the problem, I wanted to go to the biggest energy company that I could go for and learn how global energy worked. And with that, I went from chemical engineering to accomplishing the American dream, graduating from Cornell, and starting my career at ExxonMobil. So at that point in time, even though I always wanted to work in climate tech and so on, I told myself that I wanted to learn how industry works at a global scale. But at the same time, I also wasn't privileged enough to just go start a company out of nowhere, and I wanted money. I wanted to be able to help my family. And the offer that ExxonMobil gave me was 3 times higher salary than what my dad was. Oil and gas in Texas, baby. So with that, I kind of put my ethics a little bit to the side, and I kept telling myself, I'm gonna make evil less evil. That's what I told myself. And I wanted to be like the light within the darkness that would try to help things out. And I went to ExxonMobil, went to Texas, and I'll be very honest with you, had a great time the first 2 years. I was learning so much. I had great leaders. I thought I was creating a big change by building big projects that would provide access to either energy or chemicals or plastics. I was really believing into it. And there may be some merit to it, but I was not seeing the other side of it. And then on my 3rd year, I was assigned to the manufacturing site. And that's when I saw the reality of how the petrochemical industry works. The unit I was specifically in charge in basically takes the bottom of the heaviest stuff of the oil barrel, and we just basically burn it. And you produce energy as a result, and you put also some other products. And it was really difficult me driving in every single day to work because there was always a second sun. Even when the sun had not risen, there was always something burning that was so bright as the sun. And the only positive things that I can say out of this experience is that I was there when they first injected plastic waste for recycling purposes in the very same unit. And that gave me hope. It's like, oh, we're doing something great. We're finally recycling plastics. Then I realized, no, we're actually just eliminating plastic waste, which is a benefit, but we're also burning the plastic waste to produce pyrolysis oil, more oil to then be utilized in other applications. And that didn't really vibe with me. And it wasn't a culture fit. As you guys can see right now, I'm wearing a bright blue blazer. This is actually our company color. And like, I chose this. This represents me who I am. And the best way to describe me as a bird is a peacock. I have feathers that I like to show, and they're very colorful. And ExxonMobil is a land of penguins. And I refuse to put my penguin suit on. And with that, they gave me the feedback and the ranking after a year at the refinery, where they gave me the feedback of, Stewart, your positivity and confidence is perceived as arrogance and as a technical veteran. Therefore, we deem you need significant improvement, and you've been placed in the performance improvement program. Those were, I will say, very honestly, that was the hardest day of my life. I've been very lucky to not, my young life, not to have like family or personal problems. But on the professional sense, that was the hardest day of my life because I was just told that what I thought was my biggest asset was now my weakness. And I remember going home and crying to my roommates because it's like my whole dream of becoming an executive at Exxon and making evil less evil just completely went out of the window. Still remember calling my mom and her being supportive, like, we're here for you no matter what. So when that happened, I had to basically rediscover myself and start thinking, what do I want to do with my career and my life? And to this day, I can tell you that although that was the saddest day of my life, that was the greatest thing that ever happened to me. Because with that, I started reflecting on what do I want to do? What I realized is I wanted to start my own company, not only to create a positive impact with my own hands, but to create a culture that was actually inclusive of all personalities, gender identities, religions, backgrounds, something that I personally didn't see at Exxon myself. So with that, I leveraged my network from Cornell. And started thinking, what did I want to do? And I arrived into entrepreneurship. I wanted to start becoming an entrepreneur, but I had no idea how to become an entrepreneur. How do you start a company, especially a clean tech company that create a positive impact? And with that, I decided to give it a shot, and I applied to MIT for my MBA, where I was incredibly lucky to get it. And with that, I deem my days at MIT during my MBA as the happiest years of my life, because I got to meet so many great people doing so many great things in an institution that were pushing the limits of the boundaries. But even more importantly with that, I had the pleasure of meeting who I call my Macrocycle brother. Dr. Jan George Rosenboom, who is an innovator and creator of this technology. I knew I didn't have the expertise myself to innovate in the clean tech space from a technical perspective, and that is fine. What I did have was an industry background and experience that I could leverage with my social and interpersonal skills to complement a techie, so together we can bring this innovation to the world. And that's something that I learned very early on, because going back to in high school, I call her Mama Locker, Mrs. Locker, who's a science chairperson of the Kobe district, who to this day I still text and call on a frequent basis. She was the one that told me, Stewart, there's something special with you, and it's not just the way you think about chemistry. It's the way you're able to communicate your thought process. And it was that kind of like little one-liner that ever since high school made me realize that maybe I had an ability to understand technical concepts a little bit better than others. But it was the fact that I could communicate that. And that put me on a path where I always wanted to be an engineer, but I kind of realized my superpower was in communicating those technical thoughts. And with that, I met him. We decided to embark on this journey, and we have now commercialized Macrocycle to what it is today. So let me start talking a little bit about Macrocycle. And for those of you who may be chemistry teachers or love chemistry, happy to talk more technical details afterwards, but I'll try to keep it high level for this one. So when we start thinking about Macrocycle, what is the biggest problem? I actually want to ask you this question. Does anyone know where the water bottles, the plastic bottles, actually end up once you place them in the recycling bin? Anyone?
Ocean.
The ocean. Where else? Where sometimes we're wearing them.
First to the materials recovery facility in Sunset Park.
Yep.
And then they get sold to other facilities that could turn them into a water bottle, downcycle into carpets, all kind of things.
Yes. But the reality is 85% ends up in landfills and eventually to oceans. Even when you recycle them, there's a good percentage of them that do end up in landfills. Now, that material recovery facility I've actually been to myself. And they do a good effort in sorting the plastic waste. But what happens once they're sorted? If there's not a demand at the back end of it, it's just going to be tossed out because it is cheaper to throw it out than sort. So with this, we started realizing 85% of plastic waste is just cannot be used for many reasons. And this results in over 5% of all global CO2 emissions to be associated to the plastic life cycle, in its production, and its shipping, and at the end of life when it's also incinerated. And this is a big market. When you put numbers like this, people start catching attention and say, well, how can we monetize this? Right now, we have $600 billion just ending up basically in the trash. If there's a way to monetize this, now we can get the people with a capitalist hat starting to get more interested in this to be able to actually want to recycle. And with the brands, they're struggling. The brands keep making commitments saying, we're going to recycle more, and they're not meeting those. I actually just flew from Atlanta's headquarters yesterday. I was there because they're one of my customers, and they keep saying, yeah, we're trying. So our goal right now is that we want to make 100% by 2030 of all the materials either recycle or recyclable. Does that mean they're simply designing the bottle so someone else can recycle it, and as long as it's recyclable, they've done their job. And I'm not gonna tell you you're wrong because I need your money, but that's just not helping. And most brands are doing that. So what are the technologies that are trying to address this plastic crisis, and how are they working? Well, after the material recovery facilities, the predominant technology that's used in the industry is mechanical recycling. Mechanical recycling basically washes the plastics, and then you shred them, and then you use those shreds to make another water bottle. There are multiple problems with that. One, you cannot remove the colors or the contaminants that may be in the bottles. If you have a green bottle, you'll result with green flakes. So that means you cannot use it again for a clear bottle. It's not fully recycled. On a molecular level, the molecule of the plastic itself gets shorter and shorter, and that means that it gets weaker and weaker. So the bottles then start breaking apart. And contaminants like the catalysts, the metals that they use to make the plastic, they stay in there, they accumulate in there, and those are issues for the health of people that use the plastic bottles. So this has limited applications, and after a few cycles, it will have to be disposed of. You cannot use it again. That plastic is at end of life. So what is the market doing today? What the market is doing is something called advanced recycling technologies. What they do is what Exxon did, what I did at Exxon essentially, where you take the plastic and you either like burn it to an oil, or you use some chemical process to break it to its building blocks. Once you have those building blocks, then you put it back through the traditional petrochemical process to make them into the original plastic. The problem with this is you're undoing all the energy that went into making the original plastic just to make it again. It is energy intensive, it is carbon intensive, and as a result, it requires what's called a green premium, something that many of you may have heard of in the industry. Guess who's willing to pay a green premium in the market? No one. So as a result, it is a plastic that is not being adopted because it is too expensive. On top of that, it cannot be decarbonized because it uses the processes that create the emissions in the first place to make the plastic. So right now, the plastic recycling industry is just broken. So what is Macrocycle doing to resolve that? Instead of breaking the bonds and making the building blocks, we're making new bonds. We are reimagining how plastic recycling works. For the last 50 years, they've always thought you had to break plastic down to recycle it. And my co-founder thought, what if we just build it up? Kind of crazy when you think about it. It's like that simple, but like that's essentially what he did. He developed a technology where you're able to retain all the energy that went into making that plastic molecule, and you tie it with itself to create an intermediate called macrocycles. That's where the company name comes from. And what happens is when you make these macrocycles is that you can bypass the petrochemical industry entirely. Because when you open them up again, they want to go a process called ring opening polymerization. That's it. That's the most technical I'll go. And those rings want to polymerize, combine with each other to create a longer polymer chain. And if you recall, I said earlier, the shorter the polymer, the weaker the plastic. Now, the longer the polymer, the stronger the plastic. And with that, we can give the plastic its regained status to be reutilized as a drop-in solution for all new virgin grade applications. So what does our process looks like at a high level? We can take the cheap, dirty feedstock that's widely available in the market. This is literally the plastic that's nasty, dirty, heavily colored. And what we can do is that with our process, we can extract the PET plastic. So the first plastic we're introducing this is with the PET water bottles, that plastic, or the polyester that's in your t-shirt. We can extract that from all the contaminants. We then conduct our chemistry to increase the length of the polymer, and then we can remove the color from the plastic to produce a resin, the plastic, that can serve as a drop-in solution for all packaging applications or all textile applications as brand new. Now, why is this something that we're doing? You know, you may have discussed, you may have heard of like, well, we need to eliminate all plastics, we need to use bioplastics, and so on. Well, I do agree that in the long-term solution, plastics should not be in our environment. It should not be an application utilized. But what we understood is that plastic has very abundant benefits. Let's just think of medical applications and the lives that they are saves. Let's just think of how they make our cars lighter. Therefore, they make less fuel. But we cannot ignore the plastic waste in our oceans and our land. We cannot ignore the emissions associated with it. We cannot ignore the problems from a health perspective that it provides in the form of microplastic. But what happens if you eliminate all those three possibilities from happening? By diverting their plastics from the landfill, by decarbonizing the process, and by reducing the contaminants in our production that the plastic may contain. At that point, we now enable society to acquire all the benefits of plastics while eliminating the harm of it. And that's what Macrocycle is trying to do with this. And in the process, we're doing this with so much less energy that even if you use the US grid, now you're emitting 80% less energy for every ton of plastic that you produce. But guess what? It's so energy moderate from a requirement perspective that the remaining 20% can then be fully electrified with renewable energy to achieve recycling with zero carbon emissions. At Macrocycle, we believe we can fully decarbonize plastic production So it never has to be produced from oil or petrochemical means again. We're very lucky to have a strong team. I wanted to include this because I'm not here alone. I'm not doing this by myself. And all of us have taken many different paths to get here. But it's very exciting how quickly we're moving towards this. And this is right here, our first product that we have actually sold to the market. This was actually sent to Coca-Cola. And it's like, look, test it so you know that it works. And we're trying to move quick. No one is waiting for us. The environment is definitely not waiting for us. And we're actually hoping to get our first product on the shelf in the next 2 to 3 years, where you can go to the market. I don't know if it's in the US, but somewhere in the world, you can go into the market and actually be able to purchase a Macrocycle bottle, a Macrocycle shampoo bottle, a Macrocycle t-shirt, that it was made from 100% waste material and fully decarbonized. Because we're trying to basically think, okay, what is the reality of our situation? Many materials can be reused. And I 100% agree with that statement, Peter, where reuse has to be the first step. So we don't want the clear water bottles that could be reused for other things. We don't want the bottles that can be made into t-shirts. Those have their applications and they are the best things to do. We want the things that no one else can do anything with it. The ones that are diverted to landfills. So we can actually give them back again and prevent them from polluting our environment, or prevent the oil and gas companies like my ex-employer Exxon from using that as a reason. It's like, oh, we need to produce more because people need it. But with that, that is my journey. That is my team. And I am happy to answer any questions.
Okay, sorry. So this picture right here, on an atomic level, a chemical level, that is identical to the pellets that they would have produced otherwise?
That is correct. So we call this petrochemical grade. Industry uses virgin grade, but we're trying to move away from that term.
Yeah.
But this serves as a drop-in solution where all the properties are identical. The only difference is this was not produced from fossil, therefore it's not virgin. It's produced from plastic waste.
Is there an allowance for impurities, like 0.01% or something, or?
So there's always a variability in
Yeah.
the industry. The best example I can give you is like for food and beverage application, there are thresholds for everything. And as long as you meet those thresholds, it is safe and approved. So we follow the same regulations where like, maybe it doesn't have to be identical,
Yeah.
but as long as it's within the threshold, it's like it meets the same applications.
First, are great communication. Right all along. So is the idea, I mean, that's a small amount that, and I know you're sort of a startup, but is the idea that you could do that with tons of material? I mean, that's very nice. That's how they report that stuff, but is that the goal, that you could take a ton of something and there's no loss or some amount of loss and you have a ton of that stuff?
That is correct. So our goal is in the next 2 years, we're going to scale up this to 1,000 tons per year. Now, what is 1,000 tons per year for perspective? That is 2 million bottles. 2 million bottles is a good amount. But guess what? That's still nothing compared to the reality. So that's just the journey of scaling up. So if we want to produce 1,000 tons of recycled material out, the input will depend on the quality. So we are only recycling the PET. So let's say that the bells from the municipality recovery facilities give us something that's, I don't know, let's say 50% PET, 50% other types of plastics because they couldn't separate it well enough. Then we're gonna need 2,000 tons coming in. And out of the 1,000 tons of PET, we can actually output 99% of it. So we only have 1% losses. And the other 1,000 we don't dispose of. We actually were able to purify it technically, so then we can give it to another recycling partner of ours that can deal with those type of plastics. We're not going to be the only solution on this. We're planning to make a big cog as part of this solution, but we need to partner with the collectors and the other recyclers of other materials for us to work together. But that's essentially, in order to get to 1,000, that's what we need to do.
Yeah. So you're doing this yourself, but is a plan, put this technology, license it to those companies that are falling short of their goals. And so that's how you get the scales, that it's not just you, it's that all of those companies, maybe they have the ability to do this.
Great question. So I will answer that in 2 ways, the short term and the long term. In the short term, people gave us a feedback that other companies are not in the business of de-risking technologies. So they want us to prove it first. That means that we, Macrocycle, have to build those plants first. So once we prove our technology, it's no longer a risk. Now it's a business opportunity. And at that point, we transition from selling plastics to selling plants. As we license our technology for all our competitors to now want to enter to this of like, hey, like your technology works better than ours. We basically want to make it really difficult for them not to use our technology, economically speaking. And with that, we'll license our technology to increase the rate of penetration that our technology can have an impact on the world. But we need to prove it out first.
Can the chemistry behind it all, the ring opening polymerization, can that work with other plastic types, or is it only functional with PET?
Great question. Are you a chemistry teacher? No.
Status teacher.
Yes. So our technology, our platform works with up to 50% of all the plastics. So the other ones are nylons. So your leggings, our technology will also work with. There's other plastic called polyamides, polyurethanes. Our technology can work with those. The reason we're not focusing on those is that from a business decision, we need to succeed in one of them, establish ourselves, and then we can tackle the other ones. And the biggest issue right now is how the heck do we get a hold of plastic waste if no one is collecting it? PET water bottles is one of the most collected plastic waste. So it has the most supply for us to establish ourselves in the industry. And then once we're profitable, let's go tackle the other plastics.
So I just want to make sure I understand, right? You're reinforcing the plastic when you're building up the polymers again, only the byproduct. Like only of the not virgin plastic, but to take out the carbon 100%. Like you're not sourcing any other component.
Oh, yes. Yes, that is correct. So the only byproduct that so if you have, let's say 1 kilogram of pure PET, you don't have trash. The only byproduct we produce are the dyes and the pigments that we remove from the bottles. We don't put any new petrochemical, any fossil fuel, and that's why we do have a little bit of a loss for like 99% yield, where we like lose 0.01% in the process.
A question about your former boss. So like, what is your sense of the field if this really does become something? Is this something that they're like, feel like you're being watched and they'll be mimicking if it's really a profit? And like, or is this something that is like not even on the radar because it is such a small player in the field?
So it's interesting because last year I went to Houston for a conference and an ExxonMobil guy, he didn't know me, but he saw my presentation and I said, I used to work at ExxonMobil, gotta build your credibility. He approached me afterwards, we talked for 5 minutes and he's like, hey, Stewart, how can I help you? You know, it's like, how can I help you? And I was trying to be very political correct because I kind of don't like them right now, to be honest. And then he says, look, cut through the BS. Like, we want to buy you guys. And it's like, damn, take me out for dinner, leave before you tell me that. But he also told me that feedback of like, but we cannot do that right now because you guys haven't proved anything. But if you guys succeed, we'll be there. So ExxonMobil and every other oil and gas player and every other major company is in the business of making money, not creating a positive impact. And the reason I wanted to rephrase the way that I did is because I want to create a technology that becomes so economically attractive that it does not make financial sense for them not to pursue this technology. That is my personal opinion as to how we're going to decarbonize the market and force those companies to move towards our direction. If the archaic petrochemical and refining technologies start becoming unprofitable, they're going to have to move. Otherwise, they're going to be losing market share and so on. So they're all the events. So they are definitely staying tuned with all the innovation and they have the capital then to like purchase those companies and then expand it. So if you give them a path for them to become profitable, they will take it. But otherwise, any final questions? Well, yes.
How come no one else has made rings?
So a little bit of a history lesson here is that plastic has been produced now for like 100 years. And the infrastructure of plastic has been developed at a global scale. When recycling started becoming an issue, which wasn't until like 50, 60 years ago, to be honest. They started thinking, well, how can we take advantage of the current infrastructure? Why reinvent the wheel if there's already a big wheel that we can take advantage of? So in order to take advantage of the current infrastructure over the last 30 years, people say, well, let's just break the plastic down and reuse the entire manufacturing process that has already been stood up to a global scale. And that was basically the thinking for all the companies. So when I showed this, there are multiple technologies taking the plastic to monomer routes. They're either using enzymes, they're using different chemicals, they're using heat. There are many approaches, and the innovation has been what's the most efficient way to get to the starting point. But for some reason, no one ever thought, what if we never take to the starting point? What if we take a new path? And that's where my co-founder, and I call him a true genius, kind of like stumbled upon it, kind of like just like thought about it. It's like, why don't we take this approach? And fundamentally, even 3 years later, after we kind of come out to the world with this technology, no one else in the plastic space has been able to replicate us or take this approach because everyone has always thought the other way. And my co-founder rediscovered a forgotten technology and applied it to this, and it's like, it works. And that's why, like, sometimes it's better to be lucky than good, but the good people get lucky way more often than not. And that's kind of like what happened.
So you were mentioning a lot about the plastic that gets out. Is there, like, let's say like down the road, whether it's you directly or your technology, if there's plastic that's going sitting in the Pacific garbage patch, right, and it gets reclaimed, could it still be applied? And is there like maybe a look to do that in the future as well, not just from the recycling facility, but like just straight out of the future?
Yeah. Absolutely. So we actually have a batch of water-bound bottles in our lab from the harbor of Boston that a company collected and sent to us. It's like, okay, let's test it. It's actually interesting because they have a lot of salt, and salt is the biggest contaminant in those bottles, but we can absolutely recycle it. They're a little bit more weathered down, they're a little more degraded, but that's what our technology does, is upcycle the degraded material. The problem will be not with us, but how expensive is it to collect? So there's also reality that there's only so much we can do. So to give you a perspective, PET in the market sells for around $2,000 per ton. And the supply right now for us to source our waste can be from as low as $300 to as high as $1,000 per ton. And that's already of material that came from the trash bins that went through some process. Now, if someone tells me, Stewart, we have ocean-bound plastic for you, but it's going to cost you $1,500 per ton to source, I might say, let's talk later. And that's been the biggest issue when it comes to collecting plastic from the environment, is that there are not technologies out there that can do that efficiently and therefore profitably. But our belief is we're trying to start the positive circular loop. If we can be profitable without a green premium, customers will want to adopt our solution. And if we have high margins, we can afford to pay more for the supply. If we can pay more for the supply, more people will want to collect because there's money to be made there. And that will therefore drive innovation to a point where technologies for collection and sorting will become more efficient. And eventually, when we become as efficient as Europe, potentially we might have to start collecting from the ocean or from other streams because we need more plastic supply to make more money. That's the logic that we want to believe in order to increase collection. So eventually, we do hope to be constantly recycling not just ocean-bound plastic, but ocean-found plastic. By the way, let me ask you this question back. Are you aware of how microplastic is formed? Indeed. So we are going to be able to solve one of the biggest producers of microplastics, but I'm going to inform you of a bigger producer that we not address. So the one that we can address is ocean, like the sun and the temperature and the conditions erode the plastics, creating microplastic that is consumed by fish life. If you prevent plastic from ending in the ocean, you will eliminate the problem of microplastics. Their microplastics also produced through the mechanical recycling process where they shred the plastics and they make the fine dust. We don't do that. So we also mitigate the production of microplastics by eliminating the need to go through that process for a lot of material. The biggest polluter of microplastic that I recently learned just 3 weeks ago is actually your clothes. Every time you put polyester in your washer and dryer and it washes, a little bit comes off. And that ends up in the waterways, that eventually ends up in our oceans. There are technologies that can already put like basically a filter on your washer and collect all the microplastics. I don't know, actually, I should probably look into that myself.
Yeah.
You can all look into it and like see if you can install it in your own houses and homes and so on. Those technologies are available. The reason they're not being installed is because it's an additional cost for what? Exactly. So those technologies are available. And I have a friend out of Europe who's actually like commercializing that technology and selling it. So there are people working on that. That's the biggest producer of microplastics that I recently learned about that I was like, I'm shocked. Besides that, there's also like your shampoo and anything with glitter. That's also microplastics. And when you wash it off, to the waterways. So we're working on part of it, but we're going to need help for the other parts.
Plastics, of course, like the more you use plastic, like even like at your level, right? Like you have like a plastic water bottle, wash it, microplastics, and in the recycling, polymers break down. So like building up the polymer again, or splitting them, I guess, does that mitigate the kind of runoff of microplastics from the recycling process?
That's a great question. I want to say yes, but it doesn't matter. And the reason it doesn't matter is because we cannot build it up too much. If we go too long in polymer length, it actually goes outside the specs of virgin gray. So it's no longer now virgin gray. It may be super virgin gray, super petrochemical gray, but like it's not suited for the application. So the plastic that we sell, we can upcycle it, but it's to be identical to what's already being done. So our customers adapt it. I would like to say that yes. So on our side, what we're doing there is we're definitely encouraging our customers. We're going to collaborate with customers that have more than single-use applications in the longer term. Like right now, we're trying to see who are those customers that have the bigger pain points that will pay us. But as we scale up, we want to work with the customers that actually focus on reuse plastics rather than single-use plastics to like try to drive that. But besides that, it's just proper education. The leaching and the microplastics happens if you leave your water bottle in a sunny day for the sun to beat it down, it warms up, material gets weaker, and stuff like that. If there's proper handling of it, it's actually pretty impressive how much engineering has been done to mitigate the risk. But the moment that it's mistreated, mishandled, that's when those problems come up.
So I wanted to ask, because somebody asked before about the different plastic types and how you like, so are you finding, because of course more, I think like 2s and 3s, right? Like the tubs and trucks are more, like those are more, can be better recycled if companies buy that plastic and recycle it. So is that something that you find like the barrier that other people are buying that are kind of where you otherwise, but it's too expensive per ton or whatever it is?
Yeah, so 2 and 3, we cannot recycle ourselves. Those are the other 50% that I mentioned earlier. And the reason they're more easily recyclable is because they're sturdier. They don't break down as easily. So I put in like mechanical recycling, how they make the polymer shorter. Those 2 and 3 polymers actually are way more resistant to that type of thing. So they're easier to recycle. But what we found out is that by us commercializing our technology and succeeding, we're actually helping everyone. Because, for example, that bell that I mentioned earlier, that's 50% plastic, 50% other plastics. By us existing, we can make it easier for other recyclers to be able to use that remaining 50%. And we're also propping up the supply chain, incentivizing collection. So that's how we try to help our other partners in the other plastics, but we ourselves will not be dealing with it. We'll go.
One more question?
One more question?
Of having to produce more plastic in order to be able to recycle plastic.
No.
No, so you'll be recycling the same plastic that you're putting out.
Yep. So, well, of course, we don't have control over the plastic that we put out there to get it back. But by, logic in the sense of like 1 ton that we recycle is equivalent to 1 ton that we probably would have taken back. But someone did ask me once, it's like, well, plastic is gonna continue to increase in usage, so more will have to be produced. Petrochemical plastic will always have to be part of the equation. And the response is maybe feasibly, yes, but theoretically, there's enough plastic in our ocean and our landfills where we never have to produce plastics from petrochemical again.
Quality.
Yeah, so one of the things that's really interesting is our process not only extracts like the color, like I show in this slide, but we're also able to remove the catalysts and the metals that were used for the original application of paint. So we can produce a healthier plastics. Now, what we do not have control, and this is just for everyone to know, is there are things that are added to the plastic after production to make it oxygen barrier resistant or color or like heat resistant, stuff like that. Those are things we don't have any control of. But at least I can say that the plastic we produce is better for people and healthier than the petrochemical produced plastics. So again, trying to be one cog of the entire machine, and hopefully we can enable that change through our technology. So I presume that is all the time we have, and with that,
Are you still at your mouth? Like how often?
theoretically, we can talk more about that. But with that,
Well, you can ask that.
we'll get we'll talk about lunch. But with that, I want to say thank you so much for the time, and I can't wait to
Well, thank you so much. I think that that is a really great opportunity for us to not only learn about plastics and this new technology, but a story that we can come back to your students about, failure is not the end. So thank you for sharing that with us, and especially. We have a very short break, and then we have the panel coming up. If the panelists please come to the front, and then but we have a very short break. We really have to go somewhere. And then if the panelists please come to the front, and then we'll go back.
Oh, yeah. So where is
Boston right now. And we'll see what we build in the next one. But it will not be in Boston. Boston,
So expensive, yeah. So over the summer, I take my son up to
And echoing the message that kicked us all off, if next year everyone finds one person to bring and we need a bigger room and we need to convince people to supply a much bigger space, all the better for us, all right? So thank you all for joining. My name is Brian Deutsch. I just changed roles at Con Edison. I had been in environment, health, and safety within Con Ed's STEAM operations and STEAM world. I was very much in the operational day-to-day life, waking up and getting to work by 7 and making sure that we remain in full compliance with all the local, city, state, federal regulations, things like that. I was able to just move this week into a new role where I'm now leading the water and natural resources efforts for Con Ed as a company. So my reach will now be much bigger. Really exciting. It reinvigorated me, and I'm able to do a lot of the stuff now that we get to talk about. So I'm excited, and everyone here, I feel like I'm going to be reaching out to you all in my new role and saying, hey, how can we work together some more? So with that, I think we had a great morning where you got to hear from Peter and Stewart. Kara, I want to give you a quick chance since you didn't have an opportunity to really give some of your background. So why don't you kick us off, a little bit of background of yourself and what you're doing.
Yeah, sure. Hi, everyone. I feel like I recognize some of you from tours. Hi, good to see you all. So I'm Kara Napolitano. I'm the education director with Balcones Recycling, which is a long name that means nothing to you. But basically, we operate the city's municipal materials recovery facilities. So all the recyclables from your home, if you live in New York City, and all the recyclables from your school come to us exactly the way you put them in the blue bin, all mixed together. Our job is to sort out those materials, the metal from the glass, from the plastic, from the cartons, from the trash that people incorrectly send to us, and then sell the recyclables onto plastic reclaimers, the paper mill, glass furnaces, smelters for metal, and so on. So that's the facility's job. My job within that facility is I'm the educator. So I get to talk with all of you. I get to talk with your students. I get to talk with community members. I get to talk with product designers as well, which is of particular interest to me, about how recycling works and what is recyclable and what is not and why, and get into the weeds with folks as much as they are ready and able to get into the weeds about recycling. So I'm very happy to be here with you all today. And it was great to hear some of your questions in the previous panel, because it gives me a sense that I'm with a very smart group, which is always exciting because I like getting into the weeds with all this stuff.
Awesome.
Fun fact, we think we met in 2023.
Probably. I'm the only one that does the tours, yeah. It's only, yeah, it happens.
It was like,
So I'm going to start by focusing on going back into earlier in your career when you're in high school, thinking about our audience here. And Stewart, you touched on your chemistry background, but what in your backgrounds led you to this point? And did you go into your careers thinking this is what Stewart, you kind of sounds like you did, but to Kara and to Peter, like, how did your careers evolve? Did you always have this as a path, or was there something that kind of flipped the switch for you?
Is that for me first?
Yeah, I'll start with
Okay.
you.
Yeah, so I knew early on that I wanted to be either an engineer or an architect. Not that I really knew what that was, but I wanted to figure out how to design those cool tall things that I would see when my dad would take me into Manhattan. What I wish I knew at the time in high school, and I remember a specific conversation I had with my literature teacher at the time, was I was asked, why are you going into engineering? He goes, really love math and science, and I really don't love reading and writing as much. And eventually in my career, I found out that it's actually the most important thing about what I do at my level now is communicating the design. And I feel like our industry struggles as scientists, as engineers, even physicians, where we don't do really a good job of explaining the importance of what we do or communicating our designs effectively. And unfortunately, that leaves a lot to interpretation, and it leaves a lot to politics, unfortunately. So I wish that even in an engineering or STEM focused environment, that clearly communicating and presenting in a crowd like I am here today is a fundamental part of that development process.
Completely agree. How about you, Kara?
You want me to go back to high school? Is that what?
Any point in the
How it
process,
got- yeah.
how you ended up here,
Yeah,
and
sure.
and what were the key points in your life really that got you to this point?
I've always been an educator, I think, in one way or another. And I've done that. I did it in the theater arts for some time. I worked in social work for some time. And then I really realized that it wasn't just people that I was concerned about, it was the environment and that reciprocal relationship between human health and environmental health that really goes back and forth. And so I don't know what I was going to do. I was in theater, I was in social work, I was all over. But then to kind of delve into that environmental industry, as an educator, hopefully I started volunteering for places like Grow NYC or like Earth Matter Farm to get more experience in waste, because I'd become very concerned about waste specifically as an issue. And like my little origin story is just, Christmas morning, and you look around after everyone's so happy, they have all of their things, and there's just like trash and wrapping all over the floor, covering the floor that was used for a very short period of time. And now no one even thinks about it. It's just waste. And just looking around and thinking, no one is talking about this, but I think this is a problem. So I became someone who talks about that every day and tries to, shine light on the fact that it's kind of a problem, the way we interact with materials and how we kind of see them just as throwaway items. And we kind of miss all of the inherent value and resources and energy and work that's gone into these materials. So trying to shine a light on that and the concept of, a circular economy, reducing, reusing, and as a last resort, recycling. So with my experience as an educator and some of the volunteer opportunities I got to participate in, I got a job at my current location as an intern in my 30s. And then ended up being able to be the educator at the facility.
And you guys heard a little bit about my story, but I guess something I didn't mention is that when I was a kid, I always wanted to be an engineer, because like engineers solve problems. That's all I knew. And I wanted to solve problems. Back then it was the power going out every other day in the Dominican Republic. And I love math, so it makes sense for me to become an engineer. And it wasn't until high school when I fell in love with chemistry that it's like, oh, I love chemistry. I wanted to be an engineer, chemical engineering. And I went into energy, as I said for the story. And I do think Exxon was a little bit of my deviation that I kind of needed to get where I was, to show me reality. But I would say that I think I was meant to be here. It's just I needed to go through all the trials that I did to be able to get there, to be an engineer in the energy industry that eventually become more the energy climate industry.
It's fascinating to be here for a topic that is so based in science, yet everyone has a common thread about communication as one of the big skills and the keys for success, not just in your roles, but in this whole kind of industry in its entirety. So that's one thing I'm taking away from this, and it's something that I believe in too. And there's this idea that engineers have an inability to talk or write, especially to non-engineers, but it's something that is a learned skill. It's not just a talent that some people have, definitely, but it's a learned skill. And that's another arena where I think having teachers listen to this and hear this and be able to bring that back to students to reinforce with them, instead of being voluntold to do this presentation, really seeing the value in practicing presentation skills, or just forming a simple slide deck instead of having a million words on the screen and then reading from it. Like, those little things are huge, and stuff that, I don't know, we've probably learned on the job when getting feedback that wasn't so great and being told like, yeah, that's not how you make a slide and present to people, sorry. But it's an opportunity to share that with the high school students now, so that they don't have to worry about that moving forward. So now changing courses a little bit and getting into the topic at hand, the idea of circularity. Can you all touch on specific challenges in your parts of industry for implementing circularity more broadly? What are the big picture challenges that you have? Is it just cost, or are there other larger challenges that you face? So we'll start closest to me again, then we'll start from the other end.
Sure. I would say cost is a significant factor. As always, given that especially concrete and in general, all the materials that we deal with have to pass through several hands before it gets placed in the field. Every additional penny that goes into the fabrication process is a dollar out of the end user's pocket, right? So finding incentives or finding policy that promotes the reuse of materials and the reintegration of materials that makes it that compels people to put that into their system and making is a big thing. I think these technologies are great, but as Stewart mentions, there's a lot of investment in recreating the manufacturing cycle. This isn't we can just flip a switch and all of these things come to fruition. It takes years for these technologies to become commercially available and at scale. And not only that, when you're involved in designing a building structure, you actually need years and years of scientific backing and results to make sure that it's safe for commercial use. I feel like a lot of times we see out there that products are pushed to market before we understand the full issues with them, even in the medicine industry, as we're finding, which makes me scratch my head as an engineer. I wouldn't want to use a product that I didn't see a really long track record of success. So there's some real issues there. The cost, the time cycle, and performance have been proved out. But yeah, I would say those are the primary kind of impediments to bringing these things to fruition.
Thank you for that. Kara, how about you on the recycling side?
Well, I will say that, cost is always a challenge. So recycling is a volatile market. So, we receive your recyclables, we sort them, and we sell them. And sometimes they're worth more and sometimes they're worth much less, which is an exciting journey from month to month. But, aside from that, just participation is a challenge. We want recyclables and we don't want trash. And we get a fair amount of trash. And there are a lot more recyclables in New York City that could be recovered. We have what's called a capture rate, meaning the amount of recyclables that people actually put in the recycling bin. We have a capture rate of about 50% in New York City, which isn't too bad, right? Is the glass half empty or half full? I know, but there's still so much more stuff, right? I don't want to get us into despair because we're not just all out failing, but we could be doing so much better. There's just so much more stuff out there we could be recycling and recovering. So participation is a challenge. In New York City, there's that 50%, but then there are parts of the country that don't even have access to recycling. So then there's materials that really didn't even have hope from the beginning. And then there's all the reasons that people do or don't recycle, even if they do have access.
I have two, and one of them is strongly related to that, which for me is supply availability. If there's no supply for me to recycle, my technology is worthless. And I'm not saying there's no supply, but if I have to compete for a much more limited supply, I'd much rather go to a market where there's more supply for me to source from, at least because it reduces costs as there's more supply available, and it can provide a little bit more resiliency with deviations. So our investors are telling us to look into Europe as well, like not to just focus in the US, but also to look into Europe to make the best informed decision. So that's something that on my side, supply is a challenge, and with that comes education and costs and so on. Two, the second one that I mentioned is investments, access to capital. I was very fortunate to raise a round of financing that has now allowed me to scale up my technology to the next stage, but it took me 23 months. Even with the story that you heard, it took me 23 months to raise a round of financing. And I had multiple investors telling me, I'm not investing in a waste solution because there's no money to be made in waste. They rather put in hydrogen, in electric cars, and electric vehicles, which some percentage or some amount should go into those, but we cannot just neglect this. So we are trying to basically make it more attractive, but we do need, on the other side, investors to be willing to be able to resolve this problem and be able to put the capital. And at least, not to get political, but with less federal support, we need to become more creative in accessing new ways of capital for us to be able to build the plant. Recycling facilities are not cheap, whether it's concrete or plastics. You still need to put a lot of steel in the ground to be able to manage all of that. And that takes millions of dollars, and the capital needs to come from somewhere.
So to that point, is there a possibility, flipping a negative to a positive, that let's say if the market isn't just on a constant upward trend, would investors be more likely then to consider either a longer time horizon for their return, or not expect such a high return on their dollar, and maybe just by chance there could be a positive effect for you by not having a booming market? This is one of those questions that is just coming to me as you're talking.
That's a tough question.
Yeah, I know. I'm just thinking about this, and maybe investors' mindsets could change if the market isn't just constantly going up.
I don't know. And the reason I say I don't know is because the times where the most investments were put into new innovations and capitals were when interest rates were at the lowest.
Mhm.
Because that means there was no other avenues but like venture capital to invest in. So if the market is slumping down and interest rates are still high for whatever reason,
Well,
it does
yeah.
not resolve the problem of access to capital. So I may be more independent, it may be beyond that.
Mhm.
Other factors may be driving that.
Yeah. No, I get that.
Yeah, I would say in my world where projects have to go through public approval processes,
Mhm.
that it's not always a zero sum game in terms of reaping the maximum profit day one. I mentioned 270 Park, right, as an example. Did they have to put glass policy in there? No. But I'm sure to get it through approvals with community boards, city agencies. Not only that, I think there are some owners out there that are intrinsically invested in the environment and want to build facilities that are more energy efficient, that are more thermally efficient as well. So I think there are those things there, but we have to make sure that as the public constituency that we're getting involved in that process and going to those community meetings and trying to understand what are you doing to make sure that this project is gonna lessen the impact environmentally on the community and the greater New York City area at large. So there are ways to push that beyond just the pure financial day one costs.
Now, to that point, when you began in your role, how much did people think of the importance of attending community board meetings and understanding kind of that side of the business? And has that changed? And is there more of an acceptance of that as part of the process now?
It is. It is a part of the process, especially on larger projects, more impactful projects on a community. Going through a community approval process is something that's becoming more and more commonplace. Being able to sell a project to the public, you have to be able to broach these subjects and substantive issues. Otherwise, you're going to get a lot of angry people calling the local congressman or local senator. So it's incumbent to be able to have a knowledgeable population that can ask these tough questions on some of these projects and these developers to understand what are you doing to make sure that we're putting our best foot forward from a public, especially where there's investment being made by the government in terms of reduced tax burdens and liabilities and things. There's a public cost there, right? So what's the return on that investment?
Yeah. So again, we're hitting on the idea of communication and being able to communicate not just to people in your own field, but to the general public as being really key to this moving forward.
Sure.
And Carrie, you said part of your job is in engagement with the local communities and everything. So how does that look? And have you seen any change in the time you've spent?
Yeah, so the time I've spent, there was this big, I've been working at the facility for 6 years, and right in the middle of that, this really big thing happened. There was a global pandemic. So I would say that, we were on a track kind of where in New York City, we were recycling a little bit better. The numbers were going a little bit in the direction we wanted, right? They were going in the right direction very slowly, basically. And then this pandemic happened, and after that, there was another, in-depth study done. It's called the Waste Characterization Study. Great reading, very digestible, very colorful, right? Excellent charts. I recommend checking it out. New York City's Waste Characterization Study. But the one we got after the pandemic showed that the numbers were going just a little bit in the direction we didn't want. The one number going in the direction that I liked is that the overall amount of trash that we create in New York City is going down. So that's interesting, isn't it? But the amount that we're correctly putting in recycling bins, or the amount of trash we're putting in recycling bins, that all went in the directions we didn't want. So unfortunately, that's what I'm seeing right now. But I'm also seeing product designers coming on more tours, and I'm seeing them list, because they all have sustainability coordinators. I know schools have sustainability coordinators. All those big companies have sustainability coordinators, and they're starting to listen to them now. It's starting to be a role that they say, oh, you exist and you have something useful to say. When I first started, product designers would come and I'd tell them, here's what's recyclable about your packaging, and here's what's not recyclable about your packaging. And they'd be so shocked. Oh, I've never heard this before. And now they come and they already kind of know. They kind of know these guidelines, and they just want me to explain the why and kind of paint the picture for them. So that's interesting and somewhat hopeful. There have even been a couple of designers that have changed their design after something I said to them, and some say they're in the process of it. Supply chains, it just seems to take forever. So that's somewhat hopeful. And also just meeting with your students and the questions that they ask and the engagement. I don't know if I can say that's something I've seen change, but it's something that definitely keeps the hope and keeps the energy going, even if it's unclear kind of what direction things are going in. Yeah, curious and engaged young people is always a plus.
Yeah, maybe that's it. So again, we'll shift gears a little bit into a topic that everyone has touched upon, and that has to do with the overall policy and the current environment that we're living in. But I want to talk about your thoughts on if we will really be seeing changes in business objectives when it specifically comes to addressing climate adaptation, resiliency, or will more companies keep to what they've been doing for years? Or do you think we will see a trend of companies just abandoning what they had previously been saying and doing in the public if there are policies coming out from, let's say, the federal government that are different from where they had been in the past?
I'll get us started and provide a perspective there. So I'll talk about Macrocycle as a startup and many other startups, and then I'll speak of our customers like Coca-Cola and so on, and what I've seen them and what I believe is happening. So as I mentioned earlier, our investors started telling us that we need to start looking at Europe as a potential market, and that didn't happen until November. And the reason for that is a lot of the tailwinds that assisted in pushing innovation to the market have since disappeared. Not saying that there are none, but there's so much less now, or we believe there will be so much less now when things go into effect, that Europe is becoming more attractive of a market. So from the innovation perspective, I've now have heard this from multiple startups where they still want to do business in the US, but maybe US is now the first business that they do it, and they break through it in a different market. So that is definitely creating impact, because that means there's going to be more of a, maybe not a brain drain, but just a lag when it comes to innovation, because it's all circular, and like new startups foster inspiration in other people that want to do more startups and so on. On the company side of things, Coca-Cola already pushed back their mandates from 2025 to 2030, and what's preventing them from doing it again from 2030 to 2035? The reality is they're not going to go full speed ahead towards a change until they're penalized for not changing. And if there's not federal or state, California is doing a good job with that, and New York is second, unless there's federal or state regulations that penalizes them for not changing, they're not going to change. The only way they're going to change if there's money to be made. And marketing of sustainable materials, there is some money to be made there, but there's a limit as to how much more people like us may be willing to pay just because something is zero carbon emissions, especially if we have to feed our families and put food on the table. So with that, I don't see the marketing tactics at those companies changing, but the reality of things will keep getting pushed behind until they are forced, from an economical perspective, to have to change.
Peter, how about you? What are your thoughts?
I would say, fortunately, the construction industry is a local regional industry and market, right? So we do live in an environment in a region where our mayor, our governor, our city council are pushing forward laws and regulations that are compelling these changes from an environmental perspective. So that's a good thing. And I will tell you that there's no more dynamic market than New York City when it comes to development and construction in the country, bar none. We do work all around the country. Our transit system is I would say the largest and most vibrant. It does require a lot of investment, right? And I think that we are fortunate to be in a place where, even though there are impacts from a federal perspective, that a lot of what we do and a lot of the change that's happening with concrete production is being done at a local regional level. And I still think the bus keeps moving forward. And at the same time, when we're communicating, it's important to understand that this isn't a pass-fail black and white scenario. This is every change that we can impact is a positive change in the right direction, right? So it can't be it's all or nothing, doom and gloom. It's got to be, what can we do today? What can we do tomorrow to keep progressing and moving the ball forward? Because the prevalence of severe storm effects, right? How quickly they come and how often they come is directly impacted by how many of these measures we can put forward.
Yeah, absolutely.
Yeah, I'd love to add to that, sort of piggybacking on what you said, that, the large corporations, what will they do right by the environment? If it makes them money, yes. And to some extent, they are making these commitments. So they're doing something, but what's going to really drive it right now, what it looks like, is legislation. I'm not looking to any federal legislation, obviously, but states are passing legislation to move this needle. You mentioned California; they are passing. 5 states now have something called extended producer responsibility. I'm not sure if you spoke to that at all, but it extends the responsibility of the producer. Okay, you made that. You also have to help municipalities pay to manage it once it becomes waste, because right now that completely falls to municipalities and our tax dollars. But the 5 states that they're sort of working out, California is one of them, Maine, Oregon, Minnesota as well, Colorado, but they're working on setting up what that program will look like within their state. It's going to help them fund recycling. It's going to help them fund waste management. And an idea is that it can also drive producers to do better, to produce better, to make things that are easier to recycle or reuse, or maybe even contain less toxic chemicals. That can be a part of it as well. New York has been trying to pass extended producer responsibility for a few years now. Hopefully this will be our year. But there are other forms of legislation as well. California is working on truth in labeling. So you can't have that recycling symbol on it unless we have deemed it truly recyclable, because it is the Wild West out there with labels right now. There are just not real laws about it. So I will tell you right now, you cannot trust it. If a thing tells you it's recyclable, you cannot trust it. You have to look at the list of accepted items in your local municipality to know. So right now what I'm seeing is really statewide legislation to help with that.
To add to that, my co-founder gave a TED talk where he basically said the label have created something that we don't necessarily need, which is wish cycling.
Yeah.
You place it in the bin and hopefully gets recycled.
Please don't do that. Look at the list.
So a similar follow-up, if you could think of 1 or 2 investments or incentives that could be instituted that would really push forward progress in your particular fields, what would those look like?
I want to invest in reuse. reuse is the obvious next step that we're moving towards very slowly. We are dug deep into a single-use culture of convenience, and recycling can help us climb out of that a little bit. It can help, but one thing that I stress as a recycling educator is that recycling alone is never going to be the solution. We rely on it heavily right now, and we shouldn't stop doing it. We just need to identify what it's there for and what are its limits and what is its place in waste management and in hopefully building a circular economy. But Balcones were owned by closed loop partners. They're an investment firm. They invest in the circular economy, and they're doing really great reuse pilots across the country. But that's what's happening with reuse right now. It's pilots. It's small fringe programs, and I just love to see more of that and a growth of not just a pilot, how we can really integrate these programs. And then, of course, thinking of incentives, I would love more ways to incentivize people to recycle. Anybody have any ideas? I mean, we have something called the bottle bill where you get 5 cents back if you redeem certain items. But I think that's kind of something that I see that's missing. We have education, and it's pretty convenient to recycle. You put it in a bin, you put it at the curb. It's pretty easy. The Department of Sanitation comes and gets it. But what's actually driving people to do that in part? Like, why? Other than maybe you feel kind of good when you do it. Like, you don't really understand the benefit that it has. So what other incentives can there be?
Stewart.
I don't have a specific legislation in mind, but it's more of like Europe. If anyone has been to Europe, you've seen 7, 8, sometimes up to 16 different bins for every single item possible. And my co-founder is German, so he grew up in Europe, and he told me that when growing up, everyone gets educated on that. So part of the education job is there a way that we can actually streamline that towards the education system, younger and younger, make it part of the curriculum? You guys can really help with that. But even if you guys educate the students, the infrastructure is not there. So what's the point? It's kind of the chicken and the egg, which one needs to come in first? So getting closer to Europe will really help with that. And then another one is sometimes we do need aggressive legislation. One I mentioned specific that is not a fit all for all the states or all the products, but Massachusetts banned textile from ending up in our landfills. So that means that any retailers or commercial producers cannot dispose of textiles to landfills, cannot just throw it out. They need to be collected. And as a result, as I also recycle polyester, that has massively boosted my availability for supply of polyester. And now I have a fighting chance to recycle it. Now, what are the states doing? They're selling it to a company that collects it, and then the collection company ships it out to another state to landfill. So it's just passing on the problem to someone else, but at the very least, there's a middleman now.
That you can intercept. Yeah. But sometimes it needs that step first. Sometimes you can't get to that final solution the ideal solution without a middle step that doesn't sound that great. And initially everyone cringes, but it at least provides an opportunity now that didn't exist before.
Correct. And so I don't know what it looks like in other states for other types of waste, but that one for me, at least in Massachusetts, I know who to reach out to in order to get that waste before it goes to landfill.
How about you, Peter?
I would say that there could be more incentivization in building for resiliency. The unfortunate way our construction and economic cycle works is we wait for things to break, and then we end up paying 5 times more to fix it. We have entire regions that are susceptible to wildfires, but yet we keep building stick frame construction and watch it go up like a tinderbox every time. So it would be much better to incentivize folks to maybe raise above the design flood elevation, or use concrete instead of wood, if you know that wildfires are a major thing. And now I don't think there's enough of that understanding from a risk hazard mitigation standpoint. What are the main primary risks that a region faces, and how do we incentivize folks local? Like, yes, FEMA does fund some of these efforts, and it's a very long and arduous anyone that has gone through a FEMA-funded process. It's very, very difficult and complex from a permitting standpoint. There's really nothing at the local level for that type of resiliency funding and thinking. So I think there can be and should be done. There should be a lot more, especially as we're getting into more and more extreme weather events.
Do we have time to open up if there are questions in the room?
Yes.
All right, definitely want to open it up. We'll start in the back and then we'll move forward. Yes.
Such 70%. We're getting there. So I'd love to hear, not only our individual consumption, right, which is something that we can all influence and make more conscious choices. I see a lot of plastic water bottles. And then also procurement policy at schools, in companies, and at least to put on the table the ways to influence that, so that there's more collective conscious choice. And I'd love to hear any comments on.
Yeah, gosh, I remember the mayor did a press conference at our facility where he said, I don't know, one of the house mayors, where he signed something saying, I don't know, all city buildings wouldn't use single-use something or other anymore, right? So these are things we can do, in our bubbles for school. I think all DOE schools now have compostable plates and spoons.
Compostable spoons that come in plastic.
Yeah,
wrap.
yeah. And yeah, yeah, yeah.
Obviously, that's
Yeah.
the plastic wrap is a little counterintuitive.
But we're aware of the problem. We're aware of the problem, right? And it's a process. It's wonderful that you're here. So yeah, there are things that we can do, right? Sort of in our specific areas. But I feel like the first part of your question, though. Okay.
Table.
Yeah.
What you can do.
Yeah. Yeah.
Discount that we are creating the consumption.
Yes,
So,
yes. And then, and then I guess I did just want to highlight that, as much as me, I just want to buy nothing. And that's kind of what I do. I just don't buy anything ever. I also recognize that our economy wouldn't really work if we all did that. So that's we could all do to buy less, though. I will say that we could all do to buy less and reuse more. But that's a transition from a linear economy to a circular economy, right? And it's a circular economy, and that is something that closely partners, our current owners, that they are looking to build. How do we make this work for everyone in a circular format? And wow, it's a big shift, everyone. And I feel like we're just scratching the surface of the beginning of the journey, but this is where we're at, and this is where we need to be, and we need to fight hard. And right now, sometimes we're throwing pasta at the wall, but then sometimes something really sticks and you can really get some movement. So yeah, definitely don't discount your own actions, but also know it's going to take larger approaches and smaller approaches as well.
So I wanted to add to that. I recently saw a video that gave me this point that I still need to validate, but I do believe that 50% of all of consumerism in America is driven by the top 10% of the population. Meaning the remaining 90% accounts for the other half. And as a result, if you want to see where to make the biggest impact, you kind of have to look at the top 10 percentile of consumers / financial earners. And at least at Macrocycle, one of the ways that we've looked into that is how do we make the products that we recycle into a premium product? Because those are the people that we need to address the most. If you can create 1% of impact among the 10%, that goes a longer way, at least in that stat, than talking to the 90%. And at least with Macrocycle, and I feel this should apply to many other things, is like, how do we take, well, it's probably bad to mention Elon Musk, but how do we take the Tesla approach to what he did in the EV industry? For many years, no one was buying an electric car because there were not enough chargers on the road. But there were not enough chargers being built on the road because there were not enough electric cars to start with. So the way he overcame the problem over many years was by developing a highly attractive premium product that the early acquirers and customers wanted to purchase, a premium product. And then he lowered the cost barrier to make it easier to purchase electric vehicles. So that goes twofold as to how when we reimagine materials, when we reuse them, when we recycle them, how can we lower the cost barrier, but how can we increase the desirability of it? How can we turn it into a premium product? And if you do that, you're now addressing basically like if the top 10% now wants to go to thrift stores and buy secondhand clothes way more often, you've now created a really big impact.
Clothing swaps also.
True.
Best ever.
Yes.
Sure, said something before that, the amount of trash in the city is going down.
Yes,
and
the
I'm
overall
shocked
total amount of waste, recycling, trash, everything together. Aggregates it.
just
Right?
Based on Amazon delivery boxes.
Yep,
delivery
yep.
things.
I mean, I can't claim causality. I don't know causality, right? Maybe people are using less a little bit. I can't give a reason. We could probably come up with a list of reasons and it would be partly all of them. But that is the trend, you know, in the waste characterization study, that is the trend that we're seeing.
Down a little.
Down a little,
Okay.
Yeah. but going in that direction, but not going up. And our population is probably going up. Like COVID probably impacted that a bit, but yeah, it's interesting. Yeah.
And that's commercial and residential?
That's only residential.
Okay.
Commercial, hopefully in the next few years, we'll have more solid data about that. They do, but Department of Sanitation only collects from residential, which is homes and public schools and some city agencies. Commercial establishments like businesses, office buildings, storefronts have to hire a private waste company. Yeah, and they are by law required to recycle, but there's currently a little less transparency on them. We get everything Department of Sanitation collects.
Yes.
Have like a very equal
Please come on in. Yeah.
are so. Now, some of the bigger issues are, we don't know the list. We're all the way up in Israel. And we go through the part, like individual part. There's no signage about.
Yeah.
We were actually just at the very small level of trying to get the right.
Yeah, perfect. Perfect. Yeah. 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 That's a perfect place to start. And you're right, there's so much more, but your baseline is everywhere people throw things away, all bins need to be available. And then they all need to be labeled. I'm not saying people read the signs, but please give people the opportunity to do the right thing. Please give them the opportunity. And sanitation, you can get all those labels for free, you probably know. But another fun thing to do if you have the time and the kids are excited about it is to make your own signs with the specific, okay, perfect. Because then you can put the specific things that often turn up in your classroom, in your cafeteria, stick it right on that sign. Yeah.
Oh, yeah, I was just wondering, obviously 50% for New York City, same as our voting rate. But just, is there a city that we could look at and point to say they're doing a great job, we're doing an okay job, but we're doing better than these, you know, and like.
We're beating Colorado.
Beating Colorado.
Yes.
Right? So
Yes.
hard.
We're beating them.
Let's compare to
But
Philly and
they have, but Colorado now has extended producer responsibility that they're, so they might beat us. So San Francisco and Seattle are killing it at recycling because what I observe is they have been composting for a San Francisco has been composting since the 90s. It is integrated in their lives and their culture, right? So there's a lot, right? Our organic waste suitable for composting, that's 1/3 to 1/2 of everything we throw in schools. It's 1/2 of all waste generated in your schools. That is so much stuff you could be diverting from the trash. So if we can get our act together and get this composting thing going, everyone should have access now, then maybe one day we will beat San Francisco.
I have a question in the corner.
Oh, yes.
biggest issue I teach high school and dogs. Is my kids are well aware of climate issues and climate change and global warmer, like the big picture stuff. But then when it comes to my classroom, on the cafeteria, it's one of 6 schools in the building, right? I have to care about how it impacts them directly. And that seems to be the disconnect. I feel like nobody else in our school is recycling, I don't care. Right? If they don't do it, I'm not doing it. Or in the classroom, I'm gonna go to the deli and buy the plastic bag. Rather than having sustainable stuff that we have available. That's the disconnect for me that I don't always see addressed, right? They care about the environment, if not a lack of that. They're aware of the things going on in their society. They're well aware of it, and they care about it. But it's like that immediate gratification. Classroom impacts, and there are immediate impacts. They all live near our.
I think the way in maybe is not recycling then. Maybe it's something else, like something that's more directly, maybe it's heat waves, right? Or water rising or storms, you know, that we didn't used to see, or less snow, even just finding something that is changing in their reality, maybe, and using that as a way. And it's okay if it's not recycling. It's energy, or it's weather, or it's so many other things that I just invite you to explore.
So,
and try
to add to that, I don't have an answer as to how to do it, but in my circle, you know, a lot of people tell me, what should I recycle? Like my one water bottle will not create a difference. And it's absolutely right. So in my circle, at least everyone knows everyone should vote. I don't have to educate people as to why they should vote. And then I use the same logic to them. It's like, why does your vote make a difference? So if you're saying you should not recycle, but the same logic, you're saying you shouldn't vote. And at least in my circle, they're already educated and they should vote. They should exercise their civic right. And I'm able to use the same kind of logic to map it to why they should recycle, even if one vote doesn't make a difference. Now, yeah, exactly. So that's what I say. That's my circle. High schoolers, that's a different question. But if you can find that thing that they care about, it really helps.
You can also get the points for doing it.
You get a gold star.
You know, barter for something.
Well, thank you, first of all, to you all for being here and being an engaged and active participant in this discussion. Thank you to Kara Stewart and Peter, who he told me in advance that he was going to have to step out halfway through. So really appreciate all you for being here and all of you for joining in this conversation. So thank you.
We are running a little late, that's why Peter had to leave, but please have lunch.
Good job.
Selection of sandwiches and enjoy yourself, and then we're going to set up for some hands-on work.
Thank you. I'm Yedina Desmond, usually terrible at introducing myself. Is everybody here a teacher? I'm like, so I'm going to introduce STEMteachersNYC. I'm going to share a program that we've developed over, I don't know, at least 2 years now. A little bit about what we do, a little bit about the program, and I can field any questions now, but really would love your feedback at any point in time, and you can reach out to me at any time. The program is a Teaching Urban Climate Change Microcredential. It's a 9 graduate credit bearing course that's issued through City College. I kept Yell, she is our kind of like keystone. She's been our anchor at City College. For those of you who, oh, you have the power. Okay, yes, that's really funny that I thought that I would have that magic. Or I could. Oh. You have a clicker? Yep. I'm just gonna see it. So, yeah, so sharing a little bit about ourselves, connections to the careers and the partnerships that we brought into the program. It exists through partnership and collaboration, and what some teachers think about the program itself. So if you don't know about us, STEMteachersNYC came into being because 25 physics teachers left their degree programs and found themselves to be the only physics teacher for a mile. But really your questions about a standard or the bowling ball in the closet really need to be asked to another physics teacher.
So physics teachers came together and really just started to kind of like solve each other's problems. And then physics teachers invited chemistry colleagues, and then chemistry colleagues invited bio, and then we went over K-12, all subjects, and really try to do our best to kind of like listen to what is needed in the moment. Like, for example, new life science regions, we need hands-on lab space. Yo, okay, we'll do that. So that's the kind of thing we do. We also look for different partnerships and opportunities for teachers to really bring their own expertise. Something is working in your classroom, something that you are like willing to nerd out about, that your students really love. That's a really great starting point for a program, a workshop that you yourself. So we are a space for that. And I think around 2022, it was a spate of wildfires over the summer. And we thought, I mean, this is kind of like where we come from. We assume that teachers are already doing something. We assume that teachers are already doing something really great. We're like, okay, let's ask. We're a network. We're a community of 1,600 STEM teachers. That's our Google group. We have a bigger group. We sat down and asked, said, are you doing it? Would you like to share? We got 24 responses. And that, yes. So we were like, okay. So we actually led workshops. The teachers led workshops on 16 of those. And you'll see there, we did it thanks to really nice secret. After those workshops, we thought, well, can't let those just sort of disappear. What did they look like? What do they look like together? At the time, we were leading a micro-credential around computational thinking. And what happens if we kind of like brought those two together? We proposed it to City College, and they said, okay, how about 9 credits? So these series of workshops kind of evolved into this 3-course micro-credential. Then we thought, okay, has anybody done this before? We don't want to reinvent the wheel. Is this useful? Teachers want this. So we asked. Questions that we were hearing, you know, that teachers have, that students have, what in the world is climate change? How is New York City being affected? How is New York City responding? Where is the data? Where is the data coming from that the city uses? Who else is doing work? What are the careers and stewardship opportunities that exist for our students when they're in our classroom and when they leave our classrooms? Here's one. Credit, working with partners, some real examples. Then we reached out, so we sent out an interest form, get more feedback from teachers. We also reached out to NOAA, EGE, and other folks who are doing work already, and got a list of all the things that we want. Make it look, make it immersive. This is, you know, what would teachers want in a program? Immersive. So you want immersive experiences for your students, you want them for yourself too, right? Cross-disciplinary, real world is coherent. That should be up there too. Maybe it is. And not shy away from data and systems thinking. So we thought, okay, how about we do all of the above? So we tried to do all of the above. I don't know how to fit G, but it took us a year-ish, which is fairly quick, to reach out to different partners and to teachers who are already doing work related to climate change in their classrooms and in their regular organizational work. And nobody said no. So I reached out. I said, would you like to come and talk to teachers about what you do? And everybody said yes. And this is amazing. Like, it's the kind of like pre-existing kind of like agreement that this is an issue and this is something I'd love to do. It was sort of like something that was going to be like waiting for the question to be asked. So these are some of our partners. I did not explicitly get permission to use all of these logos. Paleontological Research Institution, Don Haas comes down from Ithaca, BBG, Barbara Kurlitz, just some really just wonderful partners who come to work with teachers who are in the program, and also teachers. That little picture is, I use it to introduce, I'm in there. It's from 1992, the first RIA conference. Started things. Anyway, so the program itself, the graduate program, the micro-credential, kind of brings together nonprofit partners, teachers, curriculum tools, data visualization tools, and, degree program expertise, structural expertise from City College, and local scientists to, hopefully bring coherence, more confidence around data. Sometimes it's finding the right data sets that match grade level, or your content area. Have it be flexible. Teacher said, oh, I can meet in the summer, but I can't do it during the day because I'm teaching. We said, fine. And you have to and make it relevant. Those are cohort 1, cohort 2. We meet on Wednesdays this semester. And as a result of all of that, and thanks also to the Office of Student Partnerships, last year we worked with, we had a sub-cohort of CT teachers in the program. And OSP also was very keen on highlighting the green careers that kind of we overlap with as a result of all of these partnerships. So public education, risk management, policy, we heard from the policy team at Solar One about energy policy in the city and how that's changing. Eco-informatics, green infrastructure, all of these things you kind of actually directly interact with because you're directly interacting with the people who are doing these things. This, I'll be brief. Not gonna tell me to go. This is really just an overview of kind of like each of the courses. Course 1 is around data visualization, and systems thinking. What that is kind of like locally to you as a teacher, to your school, to your students. And then the second course, we work very closely with the Parks Department, and we get to do like actual field work. We tried for all boroughs. I think we got to 4 last year. We're going to try again for all 5, really to get an overview of what's happening. How is the city monitoring things and monitoring change, and in which living systems. And then course 3, we come back to more classroom examples again, and also that's where we meet one around energy policy, and we also look at Northeast Tribal Climate Action Plans and perspectives and strategies. So I will speed through that. These are kind of examples. I can absolutely share slides afterwards for your reading coffee at another point in time. But yeah, data visualization tools. We actually get to work directly with Dr. Sanderson, Vision Maker, and other tools to kind of student-friendly tools that kind of help you ask questions about how, flooding is changing, heat mapping is changing in the city, and create ways that are kind of like easier to interact with for you and your students. Parks, it's been phenomenal. And what are teachers saying about it? Feeling more like creating more project-based work, inviting guest speakers. That was sort of one aspect of what they were getting out of it. The other is kind of like really to slow down, really think about what we're going through all together and what we can do together. Cultivating a deep love and understanding of nature is kind of like where everything is grounded, and finding a way to create a holistic and integrated approach. In fact, thank you. We are in our second cohort. We're halfway through the first semester. And this is, I don't know, I just like this picture. Somebody asked me to just sort of generally talk about climate change education and what it is. I always go back to this picture. Like, this is a human-tended tree bridge. It's alive. That's how you get to school. I can't imagine we can have that here. But, in making connections to climate change education and green careers, not going against myself, we don't need a course like this. You're definitely welcome to join. And if there's any partner that you want to work with, let me know. I'm happy to connect you. But it's not about the science only. It's not about just policy. It's about whatever is inspiring to you. Policymakers, they're constantly saying, oh, this teacher is doing this really amazing thing, but we have to make it into some, it has to be a policy that's for like 3 million people. I'm like, no, it doesn't. It just has to fit that teacher in the classroom. and they keep going back to what's already working for you, and they just want to hear stories of things that you're already doing. So, we're working on the course and trying to make it possible better, but really whatever works for you is what works. And everybody just wants to learn more from you. Reach out to new networks. It's another thing I would recommend. Build your networks, collaborate. Don't be afraid of collaborating. As I said, tell your story, and most people will say, okay. Or if you want somebody else to knock on the door for you, I'm happy to do that. And wherever your resilience is coming from, personally, at any level, bringing that to your students, it'll resonate. So it doesn't have to look like any particular way. It doesn't have to look like this course. But yeah, taking action at the scale that you're most comfortable is right. I don't know if I took 10 minutes or less than 10 minutes or talked too fast. I can answer any questions. We do a lot of things. Our Consilience Coalition has a reading group. Applied Panarchy will have a new name, Environmental Science course over the summer. That's the QR just sort of generally on the website. We have an event tomorrow. It's free. We feed teachers.
Right. Thank you so much. Sure, everybody wants to get their micro credential. Please go ahead and we'll have everything in an email for you, sent out by next week. So for sure, you'll get all of this. All right. So, thank you. All right. So, every year I try to give our teachers sort of the pieces of information that will help you convince your young people that they should make sure that they have the right green skills. So here's a BCG report. They are basically saying that there will be a $11 trillion investment and opportunity for all things green. And right now we're at 2 trillion worldwide. I think that these numbers are a little on the low side, but let's just go with their numbers, and it'll be 5 times that much by 2040. And in 2030, as we mentioned, is our milestone. It'll be more than twice, right? So let's take a look at the major areas of growth that was on the chart. So critical mineral, this is very interesting, right? Because you know what the deal is with Ukraine, right? But anyways, critical mineral demand is 100 billion right now. In 2030, it'll be 400 billion, and in 2040, it's 700 billion. Interesting, right? And those are the materials that they're looking for. But what I want you to look at for the next one is green tech manufacturing. It is going to be exploding to be $3 trillion from 800 billion now. But what I really want you to look at are these areas under green tech manufacturing, the mature modular products like solar panels. Those are all, think of them as all jobs. People who either make them, develop them, or maintain them, or put them in, install them. Those are all those types of jobs. Those are actual green jobs generally, right? And then the green industrial materials, which is what we were doing today. We're talking about all the chemicals, so all the science teachers here, all the chemicals, the glass, the racks, all those things that are created, the hydrogen. So if you have chemists, these are all the areas that they could be going into if you're thinking about how to make things more sustainable and more green. And then there's this huge area of services, $2.2 trillion, and it's only 600 billion now. So, and that includes all those other careers that you already do so much of. You have kids that want to go into finance. You want kids to go into IT or travel and tourism and transportation. All these types of services are going to have green jobs related to it. Now, these are the current demand for green jobs. So these are LinkedIn posts. So if a utility company is looking for a new talent or posting a job, 23%, almost a quarter of their postings are going to be looking for somebody with some type of green skills. So I would imagine that utilities is probably looking for somebody with like green job skills, like intensive focus on green skills. Construction, also 1 in 5, they're looking for someone who has green skills. All the way down, and you can see retail even is on there, professional services, consultants, government administration, wholesale because of supply chain. So there's so many jobs out there that that if our students, and I just mentioned that green skills are just knowledge related to sustainability or climate, but green jobs are much more extensive in green skills. So last year, the demand and the hiring rate for somebody with green skills was 29%. I don't know why it doesn't show up now, but it's 29% last year. This year, 2024, it was 54.6%. So last year it was like almost 30%. Well, if you had a green skill on your resume, you're half as likely to get the job over someone else. But in is there a missing slide? There's a missing slide to this. There's a missing slide. But in the United States, I will say in the United States, the actual number is 80%. So in the United States, they are in such a difficult situation that, let me just get the data for you. So the demand for green talent was only 9.8% in the United States because, we're behind. And so, but the supply only increased by 3%, but the hiring rate is 80%. So if you have, over somebody else who doesn't have. So if your student has some green skills, understand sustainability, they're going to have the upper hand in the hiring process. Okay. And okay, so what happens if we don't fill all these jobs? So BCG, they think it's $7 million, right? Or 7 million jobs. Well, that is they estimate that to be a 0.1 degree Celsius temperature change. Now, but if we were all working for that, we could probably do the opposite, right? Reducing the global temperature rather than sort of like playing with this possible increase in temperature. Okay, so as you know, I'm going to tell you about my program, EGE, Engineering Green Economics. So we're trying to put all these things together. We're also putting in social aspects. We're not going to lose sight of that in sustainability. And we offered seminars at the schools. You don't have to be a science teacher for us to come in and do sustainability at your school. It's, it could really be an after school program. It could be anything. We will do 8 to 10 sessions on seminars. I'll tell you what they are. We have educational materials. We have curricula. We have obviously all of our huge network of folks to come in and work with you and I think that some of our teachers certainly stay in touch with our speakers as well. So that's great. We're happy to do that. It's not a problem for us. There's opportunities for experiential activities and obviously professional development. So this is one of our former students teaching a class on energy actually. And he is at the High School of Economics and Finance. I don't know if you recognize that. That's your classroom. And so the introduction to sustainability is really for a school that doesn't have anything on environmental studies. It doesn't have anything on climate change. This is a great class because it talks about what is climate change, what is the human impact, what is sustainability, and it goes through sustainability for all these major areas: energy, mobility, materials, which we did today, food, and buildings, which by the way is how we set up our conference. Then the sustainable the case studies of sustainable firms is really for a school that has a lot of already climate change and sustainability or environmental studies in their school. So I think Staten Island Tech, we go in and we do a module on innovation. We learn about consumer packaged goods, and we do a case study on Unilever, and then sustainable oriented innovations. We talk about cloud computing, and then we do a game. So that's the game, by the way. It's the energetic game. So we talk about, how do we get to net zero on our energy grid, which is really hard to do because of transmission, because of reliability, all of those issues. But when they play this game, they realize that's how hard it is to do it and how long it would take. We bring the games for you if you don't have your sets, and we leave it with you for a month, and then we take it back. That's our case studies. So we look forward to working with you. We don't have to do a seminar with you, but we'd love to. But we can always keep in touch and get you what you need for the things that you do. I know that might not be how business works, but this is about sustainability and about climate change. So we all have to do what we can to share information. All right. Thank you so much. Obviously. And then we are to Beyond Benign. So I'd like to introduce Scott. He's going to do all the hands-on work. He's a lead teacher. He's going to talk to you about what is green chemistry, and I think you guys are all going to change your minds about chemistry after this talk. So,
I can't stand here.
And you ask for all the different types of chemicals in your school. I have the handout.
Oh, there you go. Yes.
Okay, so, and then on our link tree is all the additional materials, because they have links to lesson plans. So we put it on the link tree, so you can download it from there. But I wanted to also give you just this overall material here. Okay.
So do me a favor, as we're getting ourselves settled, please scan the QR code. You can get added to our newsletter, get feedback, because I'm going to give you a lot of information about funding projects and classes and fellowships and curricula. You're going to get a lot of free downloads and free stuff from me today. And this is the beginning of that whole process. All right, so thank you. First of all, I want to thank Kristy and WISE in general for me to come present to you guys today. I represent and work with Beyond Benign, Sustainable Education and Green Chemistry Futures. We're going to be talking about that today. First, I want to give you some context to why I'm even up here. So I am a regular high school teacher. I've been teaching for about 19, 20 years.
No,
I teach chemistry, AP environmental forensics, biology. I've taught every science in the curriculum over the course of my career, and I've worked for about 4 different high schools over that 19, 20-year career. During that time, I've flipped between being the lead teacher. I've been a collaborative teacher for schools. I've been a chapter leader. And I also have an opportunity to actually see what happens with kids when they get out of my programs. I had the fortune or misfortune of having quite a few of my high school students in my night college class picking chemistry as well. So I got to see them twice, and they were like, "I said that to you for free." So what my goals are with you today is I want to introduce Beyond Benign to you. I want to share and just give you things that you can drive. You can walk into class tomorrow with a printout from today and start teaching. So that's going to start my first conversation. How many STEM educators are in the room? STEM particularly. So science, technology, engineering, mathematics. Art teachers. Liberal arts teachers. Okay, good. Others who have not mentioned E&L, right? Spanish? Okay. Math? Perfect. Okay, so I'm going to be looking for you because you're going to be my radiometers determining whether I'm doing a good job, because a lot of this is triggered focus on chemistry, but there's a lot of interdisciplinary stuff you can bring to other areas. There's gonna be some writing conversations. There's gonna be some longer projects. And I'm gonna try my hardest to make sure you see the connection between the kid walking into your classroom tomorrow and walking out in 3 years with an interest in pursuing green chemistry education and engineering practices in their rest of their lives, making a lifelong learner. So that's part of my focus. We have to figure out how to assess and reflect on what the practices you do in your classrooms, be things students can see regularly in their lives. Is this relevant from a citizen and consumer perspective? Because that's where our students start. They start out as a citizen and a consumer first. What can I do? What am I buying for breakfast? What am I wearing on my body when I go home? How am I going to enter my door? My safety, my security, my basic needs. And how will this translate going forward? So we can address them now, but we also have to figure out a way to at least preload the content and the practices that will enable us to succeed in the areas we haven't predicted yet, to build that type of resilience in them. So I propose one of the solutions to this and the answer to this question is this organization I work with called Beyond Benign. Now, how did I find out Beyond Benign? About in 2015, I had an opportunity to attend a PD much like this one. Only I had to travel up to Stony Brook and attend a week-long seminar of classes on green chemistry education. We learned about the laboratories that they were done and that they were beginning as a company to integrate with other organizations to market ways of making biodegradable, and you're going to hear me say this a lot today, cradle to grave conversations about chemistry, which goes back into what I heard a lot of my colleagues talking about with the circular economy and the circular cycle of material use. Their mission is to empower educators to transform chemistry education for a sustainable future. And there's a lot of, since 2015, I really can't even express to you how impressed I am with how much we've grown and how much we've reached in that time. I'll be saying a lot of these things more than once, so stop me if you've heard this one before. But we had worked with about 200 universities to sign something called the Green Chemistry Commitment, which means that they actually work with schools to plan cohort-long curricula where a student will start with the end of high school, travel through college, and walk out with a job. We work with 5,000 plus faculty who teach 1.2 million students per year. I'm actually on the advisory board for that. I'll talk about that a lot more later on. I'm going to give you not all 200 today, but access to all 200 today. You'll get to see all 200, but I'm going to give you a couple to take with you. And we've gotten grants and awards from these organizations to be able to build a world where chemical building blocks are actually used every day, are healthy and safe. And you're going to actually get a chance to play with some of those chemicals today too. Hope you're ready for that. To be able to do that, the idea of green chemistry has 12 principles. How many of you are familiar with Silent Spring? Rachel Carlson. During that same time frame, there was a man named John Warner and Paul Anastas who wrote this, who started to think about what led to that incident at the Love Canal, to try to figure out what went wrong with the philosophy of chemistry, the reason why these things were happening. What was the mindset? So they wanted to shift the mindset from the way we were building chemicals at that time to what I will go over briefly as 12 principles of green chemistry, which covers 3 main areas. Building a chemical that's going to degrade before it enters the ecosystem. Building a chemical that is thought about its chronic exposure and acute exposure as opposed to simply a single use opportunity. Has to still be cheap. Otherwise, no one's going to buy it. And it has to do what it's going to do. This is based on the theory that if we fix from all different levels in a certain amount of time, hopefully in a few years, we will get to the point where green chemistry has made itself obsolete. And it's just how we do chemistry. We're just building for this type of sustainable future as opposed to building for a short term. We want to put ourselves out of business. So how we're doing that? We're doing, we do seminars like this honestly, across the planet at this point. We're international. We have people, I'm New York South. There's a person for New York North. There's a person for Colorado. We actually partner with Colorado School of Mines. You're going to hear about some classes for that later on. And we do seminars online and in person whenever we're invited and when we're available. We also work with higher education professionals. We have a cohort of college professors who actually help us to put this curriculum together to make it so that it was a bit accessible for college students and fit into their program already. And I'm going to talk more about that as well. And of course, we make stuff. Beyond Benign actually makes stuff. How many of you have heard of the great, what is it? The Great Electric Garbage Patch? Most of that's plastic. I think, Stewart was talking earlier about how the fibers get shorter each time you use them as you try to recycle them to make your new products. We were one of the companies that was working on putting that plastic into the Sperry topsider sneakers. We're one of the companies that was trying to make it, negotiate with the building block company, go nameless, to make biodegradable pieces. That was us too. What do we do? Okay, so we worked through this through inspiration. Hopefully, again, my goal is, I'm hoping I'm inspiring somewhat. Hoping I'm getting you guys excited about this so far. If we get this working, I will work with you throughout the rest of your interest in this field to build a curriculum or just drag and drop. What I'm going to give you, you can walk in and teach tomorrow. And then eventually take over a role for these type of things. Because as I will say to you later, I'm on the advisory board for the community that builds the college and the Green Chemistry College community. Because I started the program, I was a founding member, and then I stepped away trying to make it so someone else can come up and do it as well. We do webinars, I said all these things. We do webinars, conferences and symposia, Green Chemistry Connections, I give resources. We also give awards, we have fellowships, and we institutionalize. We do it through all different levels. The main two that you'll see more of are the GCTLC, which stands for Green Chemistry Teaching and Learning Community, where we give you networking, as in we post jobs up there, mentorship, that's what I was mentioning before, and clearinghouses for grants and resources. The Green Chemistry Commitment Signers is where the colleges and universities take the lead to guarantee that green chemistry is a requirement for their higher level courses in the biomedical and chemical career fields tracks, curriculum development, and connections. The curriculum that you're going to get from me, you already actually have access to it. You just didn't know about it yet, probably. It's free online, beyondbenign.org. K through 12 resources. Every single topic in chemistry is covered up there, with labs to go with it. You're going to get the New York State particular one as well today from me. It has the prep sheet, it has lesson plan, it has the handouts for the students, it has a list of materials to buy, and a lot of them are things that are at your store right now, if you act now. So you'll be able to get a lot of these things very easily. And now we're going to see why this works. So if you would be so kind, please scan this QR code, sign in with, type in the name, could be nickname, because this is part of something like your emails, but it's a game. And I want to see if you can play the game with me. Our game is to biomimicry match. There are a series of technologies that are used in society or on the verge of being used in society today that are based on the way things are already being done in nature. Let's see if you can figure it out. Let's see how 5 minutes to work that out. Let me know if everything's working. It's no longer valid. Okay. That is what happens. All right, so I'll do it the hard way. What technology do you think, always kind of back up your lessons in case things go wrong. What do you think, what animal do you think inspired technology used for submarines? Whales, dolphins, sharks, you got it. The actual scale pattern of sharks, it's when actually shingles on the animal skin, is modified to use to reduce frictions in fast-moving ships underwater. How about a termite's nest? What modern technology do you think that inspired or communicated in the real world? So I'm asking for the modern part of it. What's the technology? Building is great. Yes, it's a building. What about a building? Packaging, huh? Okay, we're getting closer. It is concrete. But what wasn't for strength? It was actually for circulation. One of the biggest problems in building technologies is how to ventilate. One of the things you'll see, one of the conversations that were happening after COVID was, why don't we just turn all these office buildings into apartment buildings? And unfortunately, because of both zoning restrictions and the laws regarding things like window use and vent placement and air conditioning, it can't be done without a major restructuring of the internal environment of an office building to make residential. For example, you have to have at least one window in every bedroom in a residence. That's not possible if you have cubicles. How about the blue morpho butterfly? What do you think that inspired? What technology or application? Macintosh, the computers? Yeah, that could be it. Other ideas? Makeup, we're getting warmer. You're absolutely right. Which is part of why it was used to inspire the color theory behind certain fields of paint. I want to make sure I get the right quote to give you as to why it is that, because I always forget this one. All right, so with I'll read you the exact thing. Like a lot of things in nature, blue morpho butterflies are very colorful. We use paints and dyes to make colors like the butterflies have naturally. A lot of the time, the paints we use have poorly made chemicals in them that are chronically toxic. The butterfly makes these chemicals without use of carcinogens and volatility. Where are we? This one. This is, I think it's my word, if I'm not mistaken. It is a medicinal plant. What's on the screen? This is a medicinal plant. What animal or creature do you think inspired us switching to medicinal plants as the inspiration for things like aspirin, things like Tylenol? What animal or natural phenomenon led to that innovation? Something that snakes would prey on, actually. A creature that snakes would prey on. Good. So we're getting, it is a mammal. It is not a mammal. Similar in DNA to us. Chimpanzees. Chimpanzees, fun fact, self-medicate. When chimpanzees are actually seen, when chimpanzees are injured or they're in pain, you can tell from their facial expressions what type of emotions they're going through, and they have a whole codex for that. What researchers would do is they literally track the chimpanzee through the forest and observe them do the following thing. They would change their eating habits based on what they're feeling. And it would usually correspond to them eating pulling the same branches or same trees or same leaves when they had the same conditions. In other words, you see one particular face on a chimpanzee, it's old. When it has that face, it goes to that tree. And they observe that over and over again. And they're like, well, the chimps don't have a pharmacy. So maybe we should be eating what they eat. Well, something like that. I went too fast. Okay. You didn't see that. What do you think glue may have inspired? Or not glue may have inspired. What may have inspired the adhesive properties of safe glue compounds, safe adhesive compounds? I hope that saw it. That is a problem, and that's why we want something safer, something that's already edible, maybe a food you already eat. Mm-hmm. Okay, it could be that. It's actually the blue mussel. The blue mussel uses a biodegradable adhesive to attach to the bottom of ships. By mimicking that, it's very similar to a barnacle. By mimicking that entrail, we're able to make a glue that would be as edible as a mussel would be, and have mussel soup. How about the kangaroo? And I guarantee you this is one where I surprise everybody. I have done this presentation many times over the years, no one ever gets this one. Let's see if you'll be the one to break the mold. What technology do you think this inspired? I heard car seats, a spring, parachutes. How long do y'all want?
Boxing gloves?
Boxing gloves? Not there yet. This was a spring idea. So it does have to do with the pouch though. So what gas do landfills release? Methane. Good. Kangaroos you know that well, depending on your sense of humor, you might recall that cows exactly, fart methane. Kangaroo pouches have kangaroos also, excrete methane. That would be toxic if it was coming off of them into the pouch where their babies are being raised. So there's a bacteria in their pouch that digests. So by studying the kangaroos, we figured out maybe we should be using that. So now there's a point. There's a point to all this, aside from just trying to, again, get you engaged. This is the engaged portion of the lesson, of the 5 E's. The point of this activity is to show the following principle. Nature has been doing chemical reactions since inception. They've been able to change hydrogen and oxygen to water. They've been able to facilitate life in complex metabolic reactions, amino acids formations. Actual biomolecules were formed before full cellular structures were formed. They aggregated into the first one of the many cell theories. Why is it that nature can do that, and we're heating Bunsen burners work under fume hoods? How is it that nature can do it in a way that does not actually decimate the environment upon which it's taking place? And we have to put on 3 levels of PPE and glasses to be able to do a what we call an organic chemistry reaction to make the basic things we would use that nature also uses. Okay. So this also ties back into, I want to make sure we stay relevant, the shifts in science practices. I know you love them. Some of you may already hate them. The NGSS, Next Generation Science Standards. So you'll see both in what we're talking about in terms of nature versus practical chemistry, the interdependence of science and engineering and technology. We're going to be asking questions and finding out to figure out these solutions to these problems. Because a lot of these problems are still being resolved or have not been completely cracked, there is a level of inquiry and investigation from every level of tackling this problem. And of course, if you can solve these problems, then you can make more applicable use of it both on the marketing scene and the economic stage. So some of the connections to NGSS from our curriculum include, but are not limited to, analyzing global challenges to specify quantitative and qualitative criteria, figuring out constraints for solutions that account for society's needs and wants. In other words, we see that society has a problem, how are we going to address it? We have to be able to use technology. So a lot of our computational models come from processing of data, immense amounts of research data. Moving forward from that, come to a conclusion by looking at patterns. Most of this, again, I'm not going to go reading through all of this. I know most of us who have seen it are tired of seeing it, and those who haven't seen it, enjoy it. But I want to give you some more background about who we are so you know where I'm coming from. So I've already mentioned John Warner. Dr. Amy Cannon was the first person who got the green chemistry PhD, actually, and Beyond Benign partners with all these organizations to both get grants, fund student research, fund our own research, like all those projects I mentioned before. All of the things I showed you on the previous slide with the animals versus technologies, those are all things we were trying to either we tried to do or we are still trying to do or we did it already. These are projects that are in production. To date, we have 215 signers, 89 international, 33% of them are minority serving institutions within the US, 59% or 126 are overall in the US, and we just got a new 3 of them since March, since January. We reach about 1.25 million students annually through conversations like this, through our internship program, through our walkthrough. We used to have a gigantic lab in Boston, in Wilmington, I think Framingham, Wilmington, Massachusetts. And I want to tell you more about the actual commitment program. So when an institution, college, joins the Green Chemistry Commitment Program with us, they are signing on to optimize institutional green chemistry journeys. So they're going cradle to grave with understanding the economic process of finding a job in green chemistry education or in green chemistry engineering. We insist on them executing the following principles: a collective voice for inspiration, a collaborative network, grants and leadership opportunities, personal development, and increased visibility. If you or someone you know would like to join our green chemistry commitment, please scan here. Because we're adding new colleges every year. We just got 3 new. If you work at one or you know someone who does, we'd be more than happy to talk to them. There's no fee or cost with the Green Chemistry Commitment Program. We help them through that process of implementing this program. And we give a great deal of support. Here's what happens after an educator is in a school where they've shifted to the Green Chemistry Commitment. 76% of them foster new collaborations with more professionals. 72% of them end up leading professional developments like this one. 80% of them end up leading green chemistry initiatives, and 78% of them will end up doing what I'm doing, but a lot more granular, encouraging their colleagues to join the green chemistry ships. And they all increase their ability to advocate, because one of the biggest problems is you want to make a change in the world, but how do you get someone to go with you? How do you be the leader in the room or the leader from behind? It requires you to actually have talking points. It requires you to know how to flex and admit when you're wrong and when you don't know, or where you're going to find out. I did this already. With that, our locations for our signers in the US are here. We have 15 in California. We have 6 in Texas. There are 8 in New York State, 8 in Connecticut, 5 in New Jersey, 9 in Pennsylvania, and I think that's Michigan, Ohio, and North Carolina. We've graduated 25. We're graduating 25% of the graduating chemists are graduating in green chemistry. 13% of graduating chemists in this area come from green chemistry signer institutions. So in other words, we've managed to increase the number of people leaving college with a green chemistry related field degree, walking into a job in that field. So to line this perfectly with the idea of both engineering and green chemistry education and increasing the output of green chemists as they come out, I want to give you our VP of Sustainability and Social Business Innovation's quote, which is that now more than ever, the role green chemistry will play in solving the challenges of today and tomorrow is clear. We need students that are prepared to enter industry and academic research with the tools necessary not to only solve technical challenges, but to also address environmental impact. All right, and again, believe it or not, that's targets up there too, for ones who paid us for the actual production of it. So now your first experience with it. So I'm going to ask one person from each table, can you grab a test tube rack from the far table? If you don't feel like doing the hands-on for whatever reason, your chemistry side, there's also a video you can scan to go through it virtually if you don't want to do it hands-on with me. It's more in the bin. Oh, there is. Everybody got one? Every table that's going to do it, got one? One more? Okay. Alrighty. Everybody have some headsets, some speakers, and some gloves. Okay. So I have to do the normal spiel. There is no, the eating time is pause for now. Do not eat any chemicals in the lab, no matter how tasty they look. When we have to smell chemicals, we must waft to get the chemicals. I know 90% of you are probably chemistry, so I'm still going to do it. I'm going to ask you if you all the chemicals are safe, but it may be annoying to have some of the chemicals on your skin. So I will reveal to you that you might want to wear gloves. You don't have to. It all rinses off very cleanly and very easily. So, but I'm just warning you, it's a little annoying at times. And I'll explain what that is. So, anyone familiar with Le Chatelier's principle? No. How about acid-base indicators? Yes. They're the same thing in many ways. Let's explain how that is. An acid-base indicator has an equilibrium. You can add a certain number of hydrogen ions to make it shift towards acidic. You can add a number of you can remove a number of hydrogen ions or add OH minus, OH plus ion. I'm getting all tied up today. I can either add H plus ions so they can shift towards acidic, or I can add OH minus or remove H plus to make it shift towards basic. This is an equilibrium interaction. The Chatelier's principle states that if you add a stress to one side of a reaction, it will shift to favor the other side. And as stress is in the reverse side, and it will shift back. What people don't often realize is the acid-base chemistry we deal with, the Chatelier's principle we deal with, exists in our daily lives. Where are my tea drinkers at? It's always a large number. Every time I do this, I love it. So let me see if I can maybe get you into a new flavor. Take a moment, take the blue test tube and open it and whack the smell towards yourself. What do you smell? What do we smell? New shoes, okay.
Ought to get blueberries later.
You're right.
Celestial seasons. And in May, it's like crazy.
This is not blueberry. What do we think?
Not COVID, can't
No, we're not drinking it. Okay, so this with the blue vial or the blue test tube is butterfly tea. I will pass this around. It is a vibrant color of blue from its flowers, like indigo. Take a chance and take a waft of the red test tube. Anyone smell anything or recognize it, or we all, as my colleague expressed, having amazing challenges? Okay, so that one is red. Now, the fun part. Here's the warnings. The only chemical that might bother you from this is the ammonia. So that can make your skin slippery. That's the one I said you can wear gloves for. It's harmless, it brings it right off, but I want to give you fair warning. I said I can trust you to pour this in your eyes or down your throats, so please don't do that. What I want you can also use pipettes to do the same thing. Here's what you're going to do. You're going to pick with your partners. You can also have more than one beaker. I think in some stations I can get you more. What tea you want to test. And you're going to put the tea you want to test into the dish or into the beaker. And you're going to test it by pouring in either ammonia or vinegar. And see what happens. See what happens. So take a risk. See what you want to test. You can test both of them. Pour the tea into the dish and then pour either the ammonia or the vinegar and see what happens. And then pour some ammonia or pour some vinegar. See what happens. What do you see? So which one turned green? Butterfly tea turned green when you did what?
Add ammonia.
Add ammonia. All right. What's happening with the red one when you add ammonia? See what happens. I think I have time.
I guess you can use this one because that's just ammonia.
If you haven't done one combination, be sure to try it. And then here's the challenge. Change it back.
Change it back.
Mm-hmm. Change it back to the color you had originally. Maybe.
With the same property.
Okay.
That's just from a Hamilton.
Okay, so it works. See, I can exercise both versions. Well, that's the beginning of it. So now, think about this. Think about the way we used to do this at the edge principle. Think about the way we used to do acids and bases. Everybody has an experience with a brewed beverage of either coffee or tea, or those who are older, something else. And these brewed beverages have effects based on the acidity or basicity of the compounds they're interacting with. What ended up happening when you tried to change the color back? So we had some interesting interactions. What do you guys do?
I don't have to write it down.
So amount mattered. Okay, what else we notice?
So it doesn't get restored fully.
Not restored fully.
A shade away.
All right. Anything new? Anything to report back? Okay. Let me ask you this. How many of you put milk in your tea? How many put lemon in your tea? You're doing the same. This worked with black tea too. Almost every tea has anthocyanins and tannins. And those compounds, was not go too deep into the woods, but organic compounds have a chirality, so they bend or flip out based on the other molecules around them and how they're interacting. One flip can make it optically active, meaning you see something different. A different flip can make it optically inactive, meaning you may see nothing. This is also the difference between things like the compound for aspirin, compound for aspirin is another chiral compound. One version of it actually does something to remove your headache. The other one is nothing, doesn't do anything. I think it's the L one that does the medicinal effect. Questions, comments, reactions? Think you can do this with your kids? Okay. It absolutely does. And the quantitative aspect of it, something I told you about the demonstration, but it's definitely something you can do with your kids. You can even do this with colorimetry. You can do this with spectral tubes. You can do this with you can do it with elementary school kids as well. You know what grade you teach, you can do it. Any level can do this. And you don't have to use ammonia. You can dilute the ammonia and then strengthen the tea. Strengthen the tea, dilute the ammonia. The little kids can do it with a drop of ammonia without having to do a whole thing that they might touch. All those things come into play. Questions, comments? So again, this QR code is the video of what you just did, basically, from our organization, from kids a few years ago. Anyone want it? I'll keep it on the screen for a few more seconds. Can easily go down the sink. Can you put cobalt chloride down the sink? Cobalt chloride used to be one of the compounds used in the Lasatte's principle demonstration. It's toxic. If I said to you guys not to eat this, every year there's some kid who tries to get to that point, and you have to do the no, run towards them. less danger with this procedure than there would with something like cobalt chloride, copper chloride, something like the iodine clock reaction. The iodine clock reaction can be done with vitamin C. There are different alternatives to this that can have the same, similar dramatic results with less toxic chemicals, that you can teach the kids to be autonomous and allow them to be able to be a little bit more safe and give them more freedom because you're not as worried about them deciding to down your samples. So as a preview, if you want to take a screenshot or something, this is what I do in my class. I do the following labs in my class. So in fall, I do exo-endo reaction, which is one of the labs we offer. What does that entail? Anyone old enough to remember pixie sticks, the sugar tubes? Those actually change the temperature of water when you put them in. They're exothermic. When you add them, because of citric acid, when you add them to water, it'll have a 2 to 3 degrees. It's not going to be a burning reaction, it's not going to boil the water, but it's going to change the water temperature by 2 to 3 degrees Celsius. In atomic structure, we do black box experiments with barbels so it's not a green chemistry experiment per se, but it is a modeling experiment. During stoichiometry, we do chemical reactions with the potato labs. So in other words, the same lab biology teachers do, I do in my class again, but now I do it with balanced chemical equations. And we're talking about the concept of hydrogen peroxide. Oxygen from hydrogen peroxide. We do acid-base, I told you about the Tyler's principle. And the one that I think fascinates most people is the BlackBerry solar cell. So one of the problems with solar panels in their current level of production is that they are like the juice box of environmental creations. What do I mean when I say that? Think of a juice box. The juice box has a layer of plastic, a layer of foil, a layer of paper, another layer of foil, and then a layer of plastic again. Why? To keep the juice fresh, to make sure no bugs and mold come in. However, where in the recycling bin do you put that? Exactly. And that means all that material goes to waste. That same concept is what happens with solar panels. A layer of glass, a layer of compounds, a layer of metal, and various other things depending on the manufacturer. When that needs to be discarded, where do you put that? You have to reinvent how to take it apart again to have that process. So one of the projects we did was to try to make as much as we could a biodegradable solar cell. And at the time, we got to a certain point, we went to a different direction. But when we got to a certain point, one of the things we found out was that you can use the anthocyanins from blackberries and blueberries as the photoreactive film component with an iodate lead glass filter. So one side was lead, one side was iodate. If I'm not mistaken, don't quote me. And we found a way to get one component of it to be biodegradable. We're still working on the other ones. But the other part of this is, I mentioned solar cell because I mentioned how you could just download all these labs. Depending on your relationship with your budgetary secretary, all of this is also on Shop POE as a Flynn scientific box kit. We partnered with Flynn for a few years, and they now make the labs that we wrote up as box kits on Shop POE. So you can buy the solar cell, I'll get to the other ones that we have for Flynn, but solar cell, the ash water titration, which we're going to show you in a second, and the endothermic exothermic lab. Burning questions before I go forward. All right, so flame test and wood ash wood ash titration are two more labs. Who likes pizza? So one of the waste products from a pizza oven is gigantic amount of wood-based ash, and they sell it usually as fertilizer distance to add potassium. It can also be used to be in titrations. You can make an unlimited amount of unknowns by giving each kid a scoop of pizza oven ash or wood ash, have them titrated with water, and you now have a potassium basic solution. Using that with not phenolphthalein, because exophenolphthalein is very toxic, but thymolphthalein, which is a blue reagent, will actually allow you to titrate against the wood ash. Wood ash can be produced from soap making. It's from ovens, and it's an alternative from biodiesel production. So there's multiple waste. There are multiple scenarios in which this is a waste product that's just being discarded. This is another way to recycle it into the lab component. Now, the flame tests, most of the times we ended up, and I think many of us probably already heard about the incident where an individual was hurt because they put the salts into the methanol salts into the fire, and the young man was injured. From that year, flame test labs were banned in New York City. I hope all were aware of that. And the alternative to it was presented very quickly. Color flame candles, the birthday candles that have a different color for each flame. It's made the same metal ion salts. And you could have the kids look through a spectrometer and actually chart it against the individual spectral lines for each element. Each one of those candles is a different one or two elements inside of the saturated into the wick. You can, and so on the top is what I do with my kids, and then I have them look through a spectral line and see that, and then I have them match it up against the spectral lines for each element. And no, it's not easy for them. That's something that's a challenge. It takes them about 2 days to do it. If you want to quickly see some printouts for that spectrum, you can scan that code. I'll give a few seconds for those who want to do it. It's spectral codes. And then I will talk about a couple of labs. But again, my goal is to make this easy as possible. Walk out of here with your next lessons. Yes. And what did I want to talk about before with that? So this is what the website looks like. If you happen to have it pulled up, I want to just give you a quick tour to show you where to go to get the entire downloads. You would go to the curriculum section, and you go to high school. And within that, from that link to that link, then each individual, that's the wrong one. And okay, I put it in the wrong order. 1 second, please, momentarily. No, okay, I'll have to do it another way. So the labs look like this, where they give you the background, they give you all the materials you're going to need, the objectives for lesson plan, the NGSS standards broken down, and how much time it would take. So you can cut that up as you need to. It gives you every component for it. You can walk in and print from this right now, or you could just cut it up for your modifications. So this is the format it'll come in. It'll have a student sheet and a teacher page, and the teacher page has all lesson plans on it. And here is all of them for New York State. This QR code. This is something that my colleagues worked on this past summer, incorporating the NGSS principles with Beyond Benign Green Chemistry principles to make an entire year's worth of curriculum that you can download right now for free. And if not, I will also send it out with Kristy in case this doesn't work either. Alrighty, it worked. Good. Here's the context. It has phenomena-based learning tools. It uses interdisciplinary approach. It has all the real-world examples, like I just mentioned to you, with the pizza, with the tea drinking, with the pixie sticks. It works from the student perspective. It has a cooperative learning project-based incorporation, so not everything is a project, but there are culminating projects for each segment. And again, the part of the real point of this is that green chemistry is not something that lives in the laboratory outside of your experience. Ammonia is in your kitchen sink. Tea is in your kitchen cabinet. You've had a pizza. So these are things you can have, it's very easy to connect to with students' lives. And what I want to make sure, I did it already. What I want to make sure is that that's not the only thing we offer. We also have online courses for teachers. So this QR code is the same for all the next 3 slides. We have a class for middle and high school teachers on sustainable science beginning on June 9th. It is, so I hope before the price turns you away, hold the thought on the price until I get to the end of these 3 slides. I have another announcement to make that I just got a text about, but I have to make sure I say and tell you. So yes, it's done through the Colorado School of Mines. $50 to enroll, plus $7 extra to get a graduate credit from it. We also have Introduction to Green Chemistry for high school teachers, which is more expensive, but you get 3 grad credits for it. It comes towards your plus 30. Let's skip that one. We have an advanced version of it for an extra green, so you can take both of them and get a whole 6 credits for it. Again, through Colorado School of Mines. And there is 2 free programs. This is the free program I want to talk to you about. So we are, let me try to say it properly. The online courses are free to New York State teachers this year because of the grant we have. There's a fellowship program for those who've taken the advanced green chemistry course. And my colleague who also mentored me, Annette Cebollera, who is the other green chemistry lead for New York, she's in New York State in Westchester. She will mentor you for 4 months. If you sign up for a newsletter with me in the beginning, we will send you out the codes to receive the New York discount codes for the courses. So when you log in to get those courses, you put the code we give you back from the newsletter that you signed up with me in the beginning.
Do you need the advance to do this one? You have done the advance as a prereq?
The fellowship. Yes, yes, you
Following
do.
completion
Yes,
of advanced
yes,
degree,
yes, you do. Yes, you do. Okay. So CTLE credits, college graduate courses, ways to enrich your course, and ways to connect you to the higher education space. Those of you who are adjuncts or moonlight like I do, we also opened a free open access online program to connect higher education, middle school, high school teachers. And I was in charge of the high school section. We need more people to sign up and log in and put resources in, because right now there's a lot of college resources and a very low high school engagement. What we have up there, jobs. We have job offers. We have job offers for high school, for college students, and for professionals. We have over 6,000 curriculum resources, 250 published papers, and about 2,000 registered users. 70,000 site visits since the soft launch. Each one, when you sign up for that, people like me will be signing in to mentor you through the process of getting these resources. So if you get confused, there's someone there to help you. And as I said before, there's about 200 people across 200 institutions across the planet. And they told me not to show you this slide because it was too small. But it's a list of all the universities in Africa, Asia, Australia, UK, Arizona, California, Colorado, Florida, Georgia, Hawaii, Indiana, Iowa, Illinois. All the universities have signed up with our program. And I will end, I think, with the following. In order, oh no, I won't end here. Okay, I want to make sure I give you the guidance for undergraduates. This is what we talked about with when you sign up for the Green Chemistry Commitment. This is what the expectation is that colleges will do with their undergraduate students. It will require them to have a course in green chemistry and sustainability that provides the working knowledge of the 12 principles of green chemistry. They have to have an opportunity to assess chemical products and processes for green alternatives. So they have to actually build a green alternative or assess a green alternative. They have to understand and evaluate the social, environmental, and health impacts. And the expectation is that they use case studies to do it, sponsored by ACS, the American Chemical Society. I was like, might think it's the other organization. It's not that one. It's not that one. And I will end with this. The moment a chemist puts his pencil to paper, they are making determinations about the human health and environmental impacts. We have to be able to make smarter designs from the beginning, both with the things we make, the students we nurture and mentor, and the communities we build with our colleagues. I hope you had a chance to get today with us. Thank you very much for your time today.
So what is the pipeline? If we have teachers here that become a green chemistry teacher, so what is the pipeline for their students to do the undergraduate program and all that? Is there a pipeline?
There's a pipeline.
Okay.
So, see, I was in too early. These are some of my former students. That's when they graduated or when, over the course of me taking them on trips over the school years, and this is where they were when they finished. They went into behavioral sciences. They went into a scientific field from that process. They chose not to continue with green chemistry specifically, but they did go into a science field because of the program they walked through. Is there a pipeline? Yes, but we still have flexibility, and the kids still have flexibility. They have to finish the green chemistry program. They have to go into a science-related field. That part is very flexible.
So basically, what happens with the students? The students sign up for something, or how?
It has to do with their college admissions process, and that's a much more, and that's not the part I have. I don't have much, I can get back to you on that.
Yes.
I don't have much information about the admissions process. I have the other end of the spectrum.
I would love to release that to teachers.
Other burning questions?
All right. Well, you guys are getting a lot of fun today. All right. Thank you so much. All right, and last but not least, the climate leadership team will show you some more lessons. So this afternoon is all about all the lessons that you utilize in your conscience. So I'd like to invite Helen to come up and
Just
tell
like
us.
refreshing the slides. Yeah, that's-
Thank
you.
And truly, Kristy, if we can make these available too, we have some like clickable links and some QR codes, but I think just having the.
I'm a fan of using speaker notes, so when you eventually get the slide, look everywhere, there's links and all kinds of stuff embedded in the slides.
Be updated because it didn't prompt me to reload.
No, then yeah, this should be perfect. All right, so hello, great to be here. We go way back with WISE. We're both originally from the High School of Economics and Finance. We'll talk about where we are now, but WISE actually was one of the original partners with the school. So we go way back with Sheila and Kristy, and it's so exciting. Oh no, you're totally good. And so I'll let you introduce yourself first, Kaylin.
Yeah, hi, I'm Kaylin Fox. I am the Education and Training Manager at the Office of Energy and Sustainability. And prior to that, as Colby was saying, I was a teacher for 11 years. I was at the school that he was at that had a WISE program. And I also actually taught with Jess. So taught for a long time in the city and had moved from teaching to the office through the It's Climate Ed leadership team that there are some folks that are members, former members, and current members. And we're going to talk a little bit about like their function within the larger climate ed space and like what we've been able to do with the momentum that you may be starting to feel about climate ed coming into this school year. And hopefully we're going to continue on that trajectory.
And yeah, I'm Colby Zender. I am a high school Spanish and health teacher at the High School of Economics and Finance. Been teaching there for 7 years and then wear a bunch of hats in and around the DOE, sustainability stuff, teacher leader, chapter leader. And then one of my favorite roles is chairperson of this climate education leadership team. And we'll talk a little bit about the work we've done there, helping the New York City public school system implement more climate education opportunities. And then we'll dive into some resources that are ready to go that you can utilize in your classroom next week. So a quick little agenda today, just 2 little parts. First one, we're going to talk about our climate education journey, how we were able to get to some of the amazing programs that we offer this year. Hopefully you all are participating in climate action days at your school. So we'll talk about our journey from a little ragtag group of volunteer teachers into kind of this formal Plan NYC mayor endorsed climate education that we've got to at this point. And then we'll dive into some resources, some tips from our years of climate education that hopefully will be helpful to y'all in your classroom. And so first we started out again as this group of educators volunteering with the Office of Energy and Sustainability. And we said, okay, we are not teaching enough climate education.
Still true.
Still true. So how do we get more teachers to teach about climate education? And then of course we have to look at our audience. How do we best teach climate education to youth? And one of the main issues that we found out were climate education was being siphoned into the science classroom and other content teachers didn't think that they have to teach climate education. That's just something for AP Environmental Science and maybe a little bit of living environment and chemistry. We know through like all the presenters today, we've heard like, no, these are all cross-curricular issues. And a big thing is communication, and you don't necessarily get those skills as much in a science classroom. So really, we need to make sure that every single subject area is teaching climate education. But we also found out that not all teachers feel comfortable or literate enough with climate education. So there was a lack of resources, there was a lack of professional learning and confidence in teachers' ability to be climate teachers. And so we set out on this journey, okay, how do we get resources, professional learning, and enable these teachers to be climate educators regardless of what subject area or grade level that they teach? And again, it's not just looking at the teachers, we also have to look at our audience. So how are students feeling living in this climate crisis, right? And just think about us as kids, right? We already were talking about climate change, but it was this kind of far off in the future, eventually we'll get there issue. And our kids today, like they didn't even know that before. They've only existed in the climate crisis. And so how do our children feel about climate change? It's a lot of anxiety. It's a lot of really negative emotions. And so us as educators, we have to be making sure that we're not piling on, because fear and sadness and anxiety can unfortunately lead to a lot of paralysis. So this is a very delicate topic and we want to make sure that we're treating it the right way. And so we'll get into some key points about it, but a lot of the stuff that we've heard today, right? Getting into action, staying solutions oriented, while we're also learning about some of the real anxieties and fears that exist when learning about the climate crisis.
That our students are thinking about this, right? If they're having feelings about it, it's definitely taking up space in their minds, and they might not be able to name it as climate anxiety or anxiety in general, but we know that they're thinking about it, and obviously we have a lot of evidence showing that they're feeling pretty intensely about it also. So we're keeping that in mind when we start building out tools. Also, we try to think about the whole student and not just the STEM or science or one aspect. We really do try to think about the whole student when we create resources to address that.
And these all look negative, but though a
Except
third of kids are optimistic, so let's foster those. And of course, this is from a few years ago and even more true today, right? Inadequate government response is causing climate anxiety in young people. They understand that we live in a world in which their concerns and their thoughts are not reflected by our government, right? Our democracy, one of my favorite graphs, shows public opinion and likelihood of something passing in legislation. And right, our corrupt democracy, unfortunately, there is no correlation between popular public support and legislation being passed. So we have to do a lot of structural reform with our democracy.
Whether it has public support or not.
Yeah, it doesn't really matter. And so connection to civics is going to be a big thing here, right? We're going to talk about the individual versus the collective. And unfortunately, a lot of climate education focuses on the individual, and we have to start to learn and practice flexing our collective muscles, because that's where all the solutions are going to be.
So one of the really wonderful partners that we have with the office and just in general in the climate space is the Climate Mental Health Network. They're a fairly new organization, but they basically looked at a graph like we had just seen and said, we really need to address this immediately and holistically. And so they developed this climate emotions wheel, which is just starting the conversation. A lot of what we're going to talk about too is starting the conversation. You don't have to be an expert. You don't even have to know what carbon sequestration is. Start talking about climate change, right? We really want to dismantle this idea that you have to be an expert to start the conversation, because starting the conversation is the most important part. And so this is just simply one taste of what they offer. I put this QR code here for the toolkit that they're developing, but they have great resources. That toolkit is really robust, but it has that SEL component, which I know so many schools are now holding time for. So you could bring them in, they'll do a virtual PD for you. Like, they have so many really great, beautiful resources that help kids manage those emotions to prevent the paralysis, to be able to say, okay, I'm feeling really scared, I'm feeling really betrayed, but I'm not going to let that make me not act, right? I'm going to use that as fuel and not as fear. So really helpful. This is truly, I'm only scratching the surface. I do implore you to go deep on this, because it's so great, and they're just getting started. This wheel is offered in 30 languages too, so super accessible.
One of the themes of this presentation is going to be use partners. This should never be work that you're doing on your own. And there's so many amazing organizations doing this work already. So it's just about kind of finding those partners, and hopefully we'll share some amazing partners that you can start working with today. And then connecting, going back to where we are, the climate crisis today and where our students are, we've reached the point where we cannot just teach climate education, right? Again, going back to maybe our childhoods, right? If our teachers taught us about climate education and it's just kind of like this, okay, we educate all these climate-minded people, and then in the future when they're all in these careers, we'll have all these climate-minded people. Like, we're way beyond that. We already need to be connecting that education piece to the action piece, because we're beyond this point where we can just let it kind of percolate, and in the future we'll be okay. We already know that we're on the path to exceeding 1.5 degrees. We are potentially on the path to already exceeding 2.0 degrees, and that's when stuff gets way, 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 way worse. Average wildlife populations have dropped by 60% in just 40 years, and as we know, extreme heat and weather events have become more frequent and severe. So just talking about the climate crisis, right? We don't want to get stuck in those negative emotions, but then when we bridge teaching about climate, teaching about crises with action, then we can get them more engaged and more productive. Linked in this slide is the Yale Center for Climate Communication. These are their 5 main principles for talking about climate education. They have a lot of amazing resources there. Again, the importance of communicating about climate change, and the Yale Center has a bunch of amazing resources. So their 5 main points are: it's real, it's crazy that in 2025 that still has to be a main point, but it is, it's bad, it's us, experts agree, and we can fix it. And of course, we're going to try to focus on that last part of the we can fix it. And I always, in pretty much any professional development that I give on climate education, and I've done talks specifically on looking at collective action, we have to talk about the dilemma of just individual climate action. Bob, I love Bob. Bob is so amazing. Bob makes sure that he separates all of his waste perfectly. He has his compost bin at his home. He has his recycle bins. Bob bikes to work. He hates cars. Bob doesn't buy new clothes. Bob goes to clothing swaps. And Bob, of course, never uses single-use items. Bob has his reusable bags that he always remembers to take to the store, just like we always remember. And of course, a reusable water bottle, right? Bob can put in so much effort into making sure that all of his individual actions are perfectly sustainable, and this is going to do absolutely nothing to solve the climate crisis, right? Bob's amazing. We need more Bobs, but Bob existing is not enough to get us there.
It's like sustainable living, right? We've solved the crisis, and now we're just responding and living in a way that makes sure that we can continue to sustain. We got to help Bob.
And we can go way deep into where this comes from. We can connect this to Coca-Cola's first ad, where they tried to push the issue of plastic pollution on the consumer and on the individual and not on corporations, right? Again, it takes collective actions, because we need to harness bringing the corporations in line. This is going to equal regulation, government changes.
Obviously, this also helps with that climate anxiety, right? Like, I made a bad decision, so I'm negatively impacting the future. And it's like, no, it's not just on you. I just wanted to contextualize what our office does a little bit, because we are talking about all the resources that we have made available for these types of things. If you don't know about our office, we serve all New York City public schools, K to 12. So if you need help with anything sustainability related, climate ed related, climate action day related, we have staff that's ready to mobilize and get into schools. You'll see who your designated sustainability specialist is. As we kind of shouted from our table earlier, all schools are supposed to be composting in New York City to varying degrees, right? Different initiatives get different teeth in different spaces, depending on time and bandwidth and dedication, lots of different things. But 50%, as Kara pointed out, 50% of waste in schools could be diverted into composting, which the composting system is not perfect. We know that changing routines is really difficult. Developing routines is difficult. Keeping them like strong is really difficult, but we do have support for you in coming into your schools, but also digitally and remotely. But this is kind of the areas where we are kind of focusing our energy, the waste reduction and recycling, including rat mitigation, which we know is a big problem for certain schools and their outdoor areas. One branch of our office does energy management and clean energy, boiler retrofits, lighting reinstalls, so getting those kind of like less the LED lights up in buildings. Our climate education leadership team is a huge part of why our office still exists, I think, but also that we're getting into schools more firmly, consistently, and constantly. And Colby is a good example of that. Jimmy, Jess, Ashley, all these folks. Green teams, we support green teams. We have a lot of different things that you can find on our hub. We have a green team classroom now. So if you have something that's awesome, that you're like, hey, I just did a waste audit. here's how I did it the easiest way. You can throw it up in the classroom. And so we also want to be enforcing this idea of support and community, right? Collective action is nothing if we don't feel like we're part of the collective, right? So that's one of the big issues that we took on this year to try to address is how do we make people feel like they are not just a Bob drop in a bucket, but the effort that they're putting in is being seen and felt around the city. Food and wellness is also a big one that we do, and the composting and the packaging, we know we're working on it. The way that contracts work, we get a little held up. Sometimes it's 5 years long, so we can't readdress that for a while, but we're working on it.
And I will forever harp on the importance of the bins, even if we know that sometimes what we put in the recycling bin does not end up getting recycled. I think bin education is a really important starting point to get kids thinking about systems and circularity and where the thing I have came from and where it goes afterwards. And even if, again, only plastics 1 and 2, New York's pretty good. We can accept a lot of plastics here, but there's issues with plastic recycling. Compost, I really feel like is a great one to teach the kids about, especially because we should have citywide composting now. So helping teach it in the schools reinforces them to compost at home. And composting is so beneficial. We learned if compost goes to landfill, that just turns into methane, which is way more powerful of a greenhouse warming gas than carbon dioxide. And if we're able to divert that 50% of school waste from the landfill, that either becomes biomass green energy for the city or soil. So it's actually fantastic. No issues with the compost. We have to fix the recycling for sure.
So these are sustainability specialists. These are some of my favorite people. You'll see that their districts listed underneath their names. You can find their contact information on our hub, but these are the folks that could come in. You want your green team to get a composting lesson? Great. You want them to come in and support you in doing a PD to the rest of your staff? They're equipped to do that. They are mobilized very heavily on climate action days, but they're constantly, it's a revolving door for them at our office. Like they are always in schools. I think we've exceeded 500 school visits so far this year. So we're a little bit over halfway, which is really impressive, but they have the skills and the resources to help you guys do these things in your school. Just reinforcing that sense of community. You don't have to do it alone. I know being an IEP writer myself, I was a special ed teacher. Asking someone to come to a meeting always feels like a favor, right? You're always asking for a favor. Could you do this? It's our professional responsibility. But sometimes when you can say, this person from the Office of Energy and Sustainability is here, and they're asking that we do blah, 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 passing that buck sometimes can be a little bit helpful in just like getting the conversation started so that you don't feel like you're putting pressure on the people in your space. We can totally take that heat and we'll happily do it for you.
Totally. I'm embarrassed to admit I've been the leader of this climate ed group in New York City, and we didn't have proper waste separation at my school. It is hard. And finally this year, after 7 years at this school, getting driven crazy by not separating, Hannah was able to work with me. And sometimes you get the right mix of people at the right time and you're able to get things done. I still have to babysit my cafeteria for 2 periods a day, but we are actually separating our waste in the cafeteria. So maybe someday it'll be sustainable.
These folks will have these conversations. The custodians are dumping everything in the same bin. That's a complaint we get a lot, right?
It will help.
Oh, well, it's contaminated. They didn't separate it right, whatever. Call them in. They will tough talk these custodians. The custodians know what to say to get out of doing the separating. But in many of them, it's not malicious. It's just the way things go. But these guys will come in and say, now that we've been here, we're setting the starting point. We want to come back and see this, how it improves. So bring them in, call them in. They are ready to go. Yeah.
They're regularly, like, they're assigned to those districts, but do we need to initiate with them or they are ready to touch?
They would be, so we have direct access and contact to sustainability coordinators in schools. So sometimes you could have a super active one. Sometimes you could have one that doesn't check their email, whatever. Anybody can reach out to them, but their main point of contacts in schools are either custodians or the sustainability coordinator. No, for sure. But
if you reach out, they'd be happy to work with you regardless. Yeah.
Set something up. They love school visits.
Just really, it's one of those things where it's like, oh yeah, like we have the different bins that are different colors, but you know, it kind of all goes in the same place.
Yeah,
like,
yeah.
You know, and then we choose the battles we want to focus on in our.
And that's 100%.
And that's like, okay, so
hand off the battle.
Yeah.
Truly,
It's a hard battle.
We know teachers don't have the bandwidth to then also be like, okay, it's March. Let me start developing a super close relationship with my custodian. Right. So they'll do the recycling. Like that's a lot to ask.
Right.
Right.
But to have a name there and
And green team, get the kids involved, having the conversations at the buildings, helping with the bin monitoring. They love doing that,
Yeah.
having
Like,
having a
identify them.
team.
They love a little swag to be like, hey, put that there. Yeah. So we kind of do it on a case by case basis. We go to schools where we visited the least. Right now, we're in the rolling out part of the composting. So schools that started composting in 2010, actually, we had schools composting in 2010, which is really great. They're re-engaging those folks. So like going back in there to teach those folks how composting works, because they, A, may have never done it, B, may have stopped doing it for a long time, or C, just need to get going. But if you reach out to them, they will come into wherever you are. What district are they? 15. Oh, also what I should mention is that District 79 and 75 are covered by all of them. So it'll be a case by case basis. If you're like, if they geographically land in some place, we'll probably send that sustainability specialist, but they all have been trained on the specific resources for those different populations. Do you have a question?
My question was about 70.
Great. Just a real quick, our impact so far, as Colby was saying, our office has been in existence for about 9 years. Last year, we first got like our teeth into the city. So we got put in the Plan NYC, which is a mayor's plan for all the different things around the city. But we formalized education in the sustainability and climate sector. So these are the things that we've accomplished so far, not just because we were in Plan NYC, but it really did help kind of legitimize our work. And we can now kind of say, like, we're two principals, superintendents, like, this is what the mayor has signed off on. Like, this should be happening because the mayor wants it. That carries different weight depending on who you're talking to, but people in general like to hear that it's coming from above. And we'll talk about this in a little bit. Our Youth Climate Summit, we did our first outdoor one on Governor's Island. We're going to be repeating that again this year, so pray for me. Our food waste prevention program, again, that's composting in all schools in all 5 boroughs. We have 100, actually this is maybe wrong, I think we're at 123 solar installations. So we have the most municipal solar of any public works in the city. The solar, and we're like dashing to get it on as many schools as we can, as quickly as we can, for reasons we don't need to talk about. We have a demand response program. So certain schools are enrolled in demand response. So on particularly bad days, we tell them to reduce their energy use. That saved us over $1 million. And we turned right around and granted that money back to schools for hydroponic towers, for water filling station, outdoor gardens, outdoor ed. So the money that we save goes directly back into climate ed, which is awesome. So
apply next year.
Yeah, if your principal is amenable, ask them to apply to demand response. We had climate action days for the first day, for the first time last year, sorry. We'll talk about those numbers in a second. And we have 808 buildings so far that have had LED lighting upgrades.
All right, and just that this is a very simplified version of our arrow, but we've come a long way. We started with this ragtag group of teachers right before pandemic started. We've been all over the place. Again, literally volunteering. We created this group of about 40 educators across the city, all different subject levels and grade levels, subject areas and grade levels. During our first inaugural few years, we were doing this investigation. How can we integrate better in science and connect lessons to standards? And that didn't work really well. No, let's start doing professional learning opportunities, giving more supports for teachers. And one of our kind of focus landing areas was this idea of a climate teach-in, which we really liked because, again, we said climate education is interdisciplinary. So this idea of a climate teach-in is getting your whole school community teaching climate in different classrooms, during lunch, after school, before school, kind of all community coming around and looking at this problem from different perspectives and different solutions. And so from that, kind of we landed on this idea of climate action days, which last year we rolled out for the first time. 4 themed days throughout the school year where everyone in the city, all of our school communities are supposed to come around looking for solutions for different aspects of the climate crisis. So we have 4 themed days on waste, energy, health, wellness, and green space and water. For the upcoming school year, we still have the health, wellness, green space, climate action day in April, and water in May that are perfect opportunities to plug in some climate education opportunities at your own school. And we have a ton of resources that we'll share about these.
So last year was our first year, and for a first year initiative, we had 1,100 schools participate. So we were kind of blown away by that, because that no initiative, first year initiative, even Civics for All, Bless Civics for All, does not get that kind of buy-in in their first year. So That told us a lot of things. A, schools are probably already doing this, and now we've just formalized the reporting of the work that they're doing. B, there's a huge appetite for this kind of thing in schools, and they want stuff. Their biggest request that they have is resources. My favorite note from this is that 84% said that it continued an action, a behavior in their school after Climate Action Day. So what we've done this year to make it a little different than last year is we focus on collective action, right? We know that bringing a reusable water bottle to school every day is awesome. That is a great way to reduce your own individual waste. That's not solving the climate crisis, right? So we have kind of adapted certain things for schools to perform all together. And if I can just sneak over here 1 second, I'll show you a collective action reporting.
It'll be real quick. We're running out of time. Real quick.
Because again, we really focused on collective action. So we wanted people to feel like they were part of a team. I'm sorry, whoever's computer this is, it feels invasive. Well, this is linked, so you guys will see this, but this is our page. You should get used to it. It has so many beautiful resources on it, but this is the Climate Action Days one. We just had Energy Climate Action Day, and the collective action, again, which is probably already happening in schools at a large scale, is turning the lights off for an hour at a time. We had 80 schools report. There's probably so many more schools that participated in this that just didn't report, but these are the total savings with just the folks that are reported. So we just are trying to show publicly what you guys can do when we work together, right? There are 60,000 or something schools in the network. It's an insane amount of 1,600 schools in the network. So even if just one school turned off the lights for 1 hour, that's a huge amount of savings.
And there's also amazing cute pictures and testimonials of different schools and how they participate. It's a great way to get some inspo for your climate action days. Why is any of this important? Obviously, we need to save the planet, but why is educating our students so important? Well, that's almost the only way. Oh, sorry, I'm going to the second point. That's almost the only way we can impact parents, right? If you are stuck in your views and you haven't really believed in climate change, one of the most powerful things we can do as educators is educating the children. Specifically, I believe it was daughters have the most impact on really. Yeah, daughter to dad is the strongest one. So the way we can get to some of these old-fashioned guys teaching the youth, and that percolates up to the parents, amazing. And then I love this study showing that 1 year-long community college course reduced carbon emissions by 2.86 tons. The average per capita emissions per person are 14.24. So that was a 20% reduction in individual carbon output just from a 1 year-long community college course. And now super quick, I know we ran out of time. We'll be very quick and you guys will get slides. I like to think about climate education in two types of ways: direct climate instruction, and we're going to give you resources where you can just teach a whole lesson that's ready to go, slides, student handouts, lesson plan, all ready, boom, boom, bang. But you will get pushback from some colleagues. You're a math teacher. I know you have illustrative math or whatever it is, and we have all this prepackaged curriculum that's gross and taking away a lot of autonomy. And I think they even tell you not to change anything. But for example, I just went and observed one of my colleagues' classes, and they were learning about rate of change, and they were looking about the number of coffee shops being opened. Like, change that data set to something about the increasing global temperature or the increase in solar installations. And you're able to then just use that as the hook into the lesson, connect it to climate, have a quick little discussion, and then move on to the math. But that's a little more beneficial than just coffee's great. You can talk about coffee shop numberings opening, but those are some quick changes where you can make climate kind of a theme of a lesson that doesn't have to be purely a climate-based lesson.
Starting that conversation.
We've heard all of these from all the speakers today, but just some quick and fast tips for teaching climate, connected to local phenomena. What are the climate things happening in New York City? Systems level thinking, learn about your students and connect it to their interests. Again, it has to be collective, connect to civics and climate action, go outside, take them to parks, interact with the natural environment, utilize partners, and stay solutions oriented. Okay, let's get into some of the amazing resources. I served as an advisory committee member and working committee member for the inaugural New York specific Subject to Climate website, which rolled out this year. Subject to Climate is one of the best climate education databases. All of their lessons are vetted by both teachers and scientists, and they have everything included: slides, student work, and lesson plan. All of it is free. I just taught a lesson segment to my Spanish 3 class looking at renewable energy, where they had to analyze different areas of the US to see which type of renewable energy would be best, look at Puerto Rico, the issues with Hurricane Maria and how microgrids are creating resiliency, like really fantastic lessons that I was able to teach in Spanish to a Spanish 3 class. Like they have all grade levels. It's not just science. So really accessible lessons for your classrooms. Again, the Office of Energy and Sustainability has a ton of resources on the Sustainability Hub linked here. They have these Climate Action Day roadmaps, which have a ton of activities and all the steps for how to do it in your classroom. And then one of my favorite things is the partner resource directory, because you have to connect to partners, let them help you teach your kids.
So you only can buy in with going to.
Oh, with the roadmaps?
Yeah.
Yes.
Because I'm also sitting in the corner, so.
Oh, yes, I love to see it.
Yes.
So it's very accessible. If you only can do 1 day a week to handle it, or 1 day a month, it'll take you through how to do it that way.
Mild, medium, and spicy.
Yeah, thank you for that. We understand that teachers have a lot of things going on. So if you're like super engaged, you want to invest a lot of time, we have some projects for you. And if you just want something ready to go that you can put in tomorrow, we also have that. And then another one, in addition to subject to climate, that I like quite a bit is another lesson database called Clean. That's regularly updated and likewise is vetted by both teachers and scientists. So some fantastic resources. I really encourage you to look at subject to climate and Clean. Ready to go lessons, amazing. I use them every year, absolutely fantastic. And
so a few
last day.
Plugs. Wouldn't be a energy and sustainability event if we didn't close. So we ever use Climate Summit coming up this year. This is the first time ever that we're opening up to middle school students. The middle school day is May 21st, which lands on a Climate Action Day for water. So this is going to be a water-centric middle school day on Governor's Island. We did it there last year for high schools, and it was a really beautiful time. I think bringing kids to the island, getting them off their phones, getting them outside was a really wonderful experience for them. We had several kids who attended, join our Youth Leadership Council, which is another way that your students can get involved. It's a really fun time. It's really great. We're going to be opening up the registration soon. So please do attend. It's a really great way to get your students motivated. And so we always try to take a top-down and a bottom-up approach. So we're putting pressure on principals, superintendents, and then we're activating kids to put pressure coming from the other way, right? So if you have those stubborn teachers who are like, it's not really my jam. They're getting that request from the top and the bottom. So hopefully we'll get full participation eventually. So activate your students. And then lastly, I will include this in a follow-up email for high school teachers, which I think you all are. Columbia Teachers College Sustainable Futures has a summer program going on. I think it's July 14th, but it's for high school teachers only. It's put on by LEAP, which is an artificial intelligence organization where they basically take you through 5 days of like in-depth science, and then you get to see how it applies to your class. There's a stipend available for it along with CTLE credits. I've been to the last two for elementary and middle, and they've been excellent. So I can't highly recommend it enough. As somebody who designs workshops and things like that, I really like the way that they roll it out. You get a lot of expertise and exposure to experts, so you can really dive deep. But yeah, really.
And this final slide has our emails that will exist on there. So please reach out to us when you get this slide deck. We're happy to connect with anyone to help you implement some climate education in your classroom. And thank you so much for your time today.
Our collective action for health, wellness, green space is going to be tree care stewardship. And we're going to open a webinar with the potential for you to get a street tree care kit to do the stewardship. So keep your eyes peeled for that, because we're giving out, I think, 50 kits. So we hope that we're going to have stewardship happening all over the city.
Parks will come to your school.
Parks will come to your school. David was here. David Stern was here from Sanitation Foundation. They will come visit your school. There's a lot out there. Visit that partner resource hub, because it's really chock full of great stuff. And thank you for letting us kind of scream at you.
All right. Well, I hope you enjoyed your day, and I do believe you probably got a lot of information today to take back and maybe even to share. We would love to work with more of your teachers, have more teachers come, get a bigger room at the UFT and all of that stuff. So we appreciate your time, and we appreciate some of you coming back year after year. And I hope to see you next year. Please go ahead and fill out those survey forms. get your CTL credits and make sure that you give me the correct email to send that to. And that will be done by, Thursday this week, and along with the decks. Okay, and so we really appreciate it. If, please let us know on the survey what we could do better. I will listen.
Kristy, this was amazing.
Oh, and here are the flyers for tomorrow's event if you're